Welcome to the meeting, September 18th. And today we have one big topic. Nicolas is going to share his X-Plane flight controller, his motion controller simulator. And we'll do that first. And then Kevin should show up at some point and share his experience with his circuit board design for his Kevinbot. And also talk a little bit about his experience with the brushless motor control. He's been using our controller boards more than anybody, I think. But it turned out earlier this week, I found out he had revision A, which we had scrapped. And so I've replaced all his boards, but he'll tell us about that. And then Chip, you'll probably update us on your progress with structures, and we can continue some of the discussion you're having with Ada and Eric. Sound good? Okay, I hear
yes,
motion
okay.
carried. Perfect. Nicolas, thanks for coming back after 2 prior attempts.
Yes, no problem. So should I start immediately or?
Sure.
Yeah, one moment. I've been struggling a bit with my audio devices.
While you get
but
ready,
I hope
we
it's
will admire your
solved and just a moment. I have yes.
So while Nicolas gets ready, are there any other topics that anybody wants to discuss, share, or ask support-related questions over, and I could fit them in too? Anything? Seems quiet. Eric, if you have any updates you want to share about Flexspin, you can do that today.
Yeah, I don't think I have too much, but sure.
People are still coming in and getting seated anyway. And thanks to everybody for dealing with our canceled meeting last week too.
It was pretty quiet.
I know you showed up. I saw. I didn't let you in the room.
Yeah, I noticed. Then I finally looked around and realized what happened. So that only made me happy when I discovered it because I wanted to wrap some other things up before the meeting. So
yeah, good.
Can everybody see my screen? I just tested it and it doesn't work in full screen mode because it's locking up my second monitor, but it should work like this.
Yeah, we have a clear view of it. Looks good.
looks good.
Okay, then welcome everybody. Today I'd like to talk about flight simulator. Here you can see my friend Sven. He has built all the mechanics of the simulator. And I have done the electronics part, of course, with a propeller in it. I'd like to divide the presentation into 2 parts. First, I want to talk about the technique of a simulator in general, and then we go to the propeller board. So what is a simulator? You can look this up on Wikipedia. It's a device that imitates or replicates a real-life process or scenario for the purpose of training, entertainment, or technical analysis. And because it's fun, we today focus on the entertainment. A simulator, the actual purpose of it is to take less resources than a real thing. You probably have seen the Sully movie with the plane landing on the Hudson River. And this is the second most important advantage of a simulator. It's non-destructive. You don't die. You can simply rewind if it doesn't work and try it once again. So how does a simulator work? It's mainly three things. The first thing is visual and oral immersion. What that means, here you can see the cockpit of a flight simulator of a commercial airplane. And it's really astonishing. You can't see a difference. Maybe if the weather is bad, there are no raindrops on the windscreen, but that's the only difference you can see. Second thing is if you add motion, then it's gives even better simulation. And of course, with the limited space of a simulator, of course you can't fly it through airspace with a simulator, and you don't have a runway. It's all you have is some meters in your own room. So all you can do is do a short move, and then you have somehow returned to the neutral position. I explain that later. The second thing you can do is you can control the acceleration vector, and that can give a really good feeling of a constant acceleration. You probably heard one expression, DOF, or degrees of freedom. That's an important thing for simulators. In the real world, you have 6 degrees of freedoms, 3 linear axes. You can move forward and backward. That's called surge, for example. Or heave moves up and down. And you have additionally 3 rotational axes, roll, yaw, and pitch. In a simulator, you sometimes have less than 6 degrees of freedom. For example, this car racing rig has only 4 motors, 1 in each edge. This is a simple push actuator actuated by a servo motor. So you can move the seat up and down, and you can rotate a little bit to roll and to pitch up or down. So what you can do to simulate real movement is called motion cueing. In the real world, for example, if you want to simulate an elevator, that's the simplest possible form of motion simulation. It has only one axis, one up and down. If you accelerate, the cabin starts to move up, for example, but you have a very long travel distance. And of course, in the simulation, you can't replicate that. Otherwise, you need a real big tower. So all you can do is to move only for a short time and then stop the acceleration and move a little bit in the opposite direction. So your total stroke of the travel is limited. But the human brain works like this. It only sees new and strong input, and if you don't have a visual reference to the outside, you don't see how fast you're moving, so you don't feel if it's moving in the opposite direction much slower. But as I already said, this works only for very short periods of time. So if we want to simulate longer lasting accelerations, we can do this. What you actually feel is all the time, of course, is the gravity. So this is force pulling downward. And if you accelerate the seat forward, the reaction forces press you into the seat. So the sum of these two vectors is the yellow vector, and it goes in a slightly different direction. You can simulate this by tilting the seed backward. So those two vectors match almost exactly, except there's a little difference. The yellow one is a bit longer, but you won't feel that. So to summarize this, this means that the simulator does, of course, not move exactly like the real vehicle. For example, take this motorcycle. If you're making a turn on the road, the force is in this direction. So it's almost 45 degrees to the outward of the turn. And in the simulator, you, of course, wouldn't tilt the bike sideways because then you would drop in this direction. And this would be a completely false feeling. Instead, you simply turn the picture and keep the seat upright, so the force goes in virtually the same direction as you would expect it. There are some limitations, of course. With such a simple moving seat, you can't simulate forces well below 1G, or you also can't simulate forces well below 1G. For example, 0G in space is impossible to simulate. So if you want to simulate a fighter jet, you could probably use one of those, centrifuge. But of course, this is also a bit too expensive for home use. So what we did, Sven has welded 2 frames of steel tubes together. There's one frame on the ground, and the upper frame has a cockpit. This should resemble a Cessna 172, which is a very popular plane. Then we have the servo motors, 2 in the back and 1 in the front. It's behind the windscreen here. Those motors can move the rig up and down if they work all simultaneously, or if you move one motor up and the other down, then you have roll around the x-axis, or you could move the front motor up and the rear motors down. Then you could pitch up. This is all controlled mainly by a PC, which does all the graphics rendering and control of the control inputs. And the servo controllers and the motion controllers in the cabinet in the rear. So this is all wired together like this. We have the main controller is the PC. The flight simulator software is X-Plane 12, and we have a separate software which does the motion queuing. It receives the flight data via UDP packets, but this doesn't go over the Ethernet. It's transferred locally. Then the output of the motion queuing software transfers the motion data via network cable to the P2 controller. And the output of this one is step and direction signals to the 3 servo controllers, which are then connected to the real motors. The servo controllers I have developed in 2014. I don't want to go into all of the details for now. If you have any questions about this, you can probably ask it later. Just a short view of the PCBs. Inside there's a power PCB and a controller PCB with the Propeller 1 on it. And then we have the main motion controller. I was able to build this relatively quickly because I already have designed the main board 1 year ago. It was originally meant as a CNC controller. And on the right side, it had 5 drivers for stepper motors. And now I have simply replaced them by simple line drivers, which output the step and direction signals to the servo controllers. On the left side, it has a port for 100 megabit Ethernet, a small display to display error messages or the status in general, and on the back side, it has connections for 24-volt input and outputs for the e-stop switch and some relays. In the picture below, you can see we have 3D printed a nice case for this. So all you can see are the external connections and the display and some wires. The software consists of the Ethernet driver. One special thing here is I don't use something like a WISNet chip. The Propeller talks directly to the PHY driver. So it bitbangs the RMEE protocol. This runs in 2 cogs in assembler. Then 1 cog does all the communication with the PC. It does the UDP and address resolution protocol. The actual motion control runs another cog programmed in C. The step and direction signal is an assembler driver I already had from the CNC controller. Then I have another cog running assembler for the I/O and safety state machine. This is probably a bit overkill for the motion simulator, but it was already there, so I took it from the CNC controller. Another component is the display driver for the OLED display. And the last part is not finished yet. If I make a real product out of this, I finally have to implement some sort of user interface, at least for configuration and parameter settings. So I plan to use the flash file system for permanent parameter storage. So why have I done this? Well, at the beginning, we tried to purchase a readily available controller, but yeah, I wasn't really satisfied with it. We had some problems with very noisy movements. I don't want to blame the manufacturer for this. He said it works as long as you use the servos he suggested, but probably our servos were just too good. I mean, they have too much bandwidth, and therefore they probably were too noisy. So what we found out, controlling the motors in such a simulator is not really trivial. It seems like you just have to pass the incoming data from the PC to the motors, but there are some problems involved. Especially the simulator software runs on Windows, and this is no real-time operating system. So you can ask Windows to do something every millisecond, but sometimes it decides to do something else. So the input data comes over either USB or Ethernet, and those packets can sometimes be delayed, or the reason for the delay, as I said, is also the operating system. And some positioning errors don't really matter. It's no CNC machine where you expect high precision. So if the servos are 1, 2, or even 10 millimeter off position, you don't feel that at all, but you can feel changes in the speed, in the acceleration especially, and the vibrations caused by data transmission errors, they can be really bad, and it destroys all the simulation feeling. So if you have small timing errors or lost packets in your data stream, you can simply apply a low-pass filter, and that smooths out most of them, but that has also a disadvantage. It always causes delay. And a small delay of maybe 10 milliseconds is no problem. But if it gets too large, especially over 100 milliseconds, it can cause motion sickness, because what you see and what you feel is different. And this can cause something like seasickness. So the situation is like this. If you, let's assume that the simulator should in reality move in a constant velocity. This means every packet you receive has a fixed number or a constant number of pulses that it has to transfer to the servos. So if they arrive in time, you simply output a constant frequency. If one packet arrives too late, you can stretch the pulses, but this is not as easy as you might think, because if one duration is longer, you have too little time for the next one. So the pulses come with a higher frequency, and this can cause oscillations. Or the worst case is the packet is completely lost, so your output no pulses at all. And the problem is, each time the frequency changes, the motor has to accelerate and decelerate, and this causes vibration, and it's not easy to get that fixed. So what the controller we purchased first did to solve this, it simply outputs a stream of pulses with a constant frequency, and then a pause when it does nothing. So this works as long as you calculate the average over a longer period of time, but of course this is terrible for a motion controller, because you always have full speed and zero speed. It's just not the way to do it. So my solution was to add timestamps to the incoming packets. And this way you can identify when a packet was delayed or dropped. So the first step is to calculate the velocity as the difference of position of two packets divided by the time passed. And with this velocity, you can use two different processes for the receiving data and the output generation, signal generation. So you can re-synthesize the original motion profile by integrating the velocity. You get back information of the position. And so if a packet is lost in the middle, it doesn't change the velocity. It simply takes the last velocity of the last packet received. But this, of course, causes another problem if the incoming packets are not exactly do not arrive exactly at the right time. You of course have an error in the position, and this error, together with the rounding errors from the division, is summing up over time. So you get a drift, and this drift has to be corrected with a closed position loop with a small gain that accounts for the error and puts in adds a correction to the position.
So Nicolas, your biggest problems are coming from the PC and they can't really be controlled, huh?
Yes, the actual errors are very small, but you have to do something against them. If you don't, they cause a lot of vibration. Especially if the data transmission is unreliable. The original controller had a USB connection, and with all the electromagnetic noise in the system, I don't know if it really caused an issue, but I have the suspicion that some dropped packets of the USB connection, well, the PC detects them with the checksums and repeats them, but this causes timing jitter, which in turn causes vibrations again because of the position errors and timing errors.
All this is controlled over, PC software is generating all this motion data that you're trying to translate into movement. Do you think if you got like a faster gaming computer and you, I don't know, dedicated like a single USB, because USBs can have multiple ports, but there also has to be like, what do you call it? There's a, it's not a hub, but like the entire USB state machine. Modern PCs have multiple complete USB state machines, right? Because they have multiple, like, I don't know, the highest level port you could have. I don't know what it's called. I don't remember, but I wonder if you could dedicate the communication through a, you know, gaming PC, that would like straighten up a lot of the data that you receive.
Yes, of course, with a better PC, it sort of would minimize the problems, or at least it gets better a little bit. But yeah, we have very little control over what's going on inside the simulation software, and we have to use this because it's simply too much work to do anything about it.
No, I understand. It is what it is. Yes.
And
do these kinds of delay and jitter problems affect the? I mean, just when you're running this on a PC without any type of motion rig, are these kind of jitter problems do they also exist within the PC between you and the controls, so that sometimes you notice this with the response of the controls that you're using? I suppose it would be a problem there too, right?
I think there is a pretty good response from the actual simulation software. The problem is probably when it comes to multitasking, when a second program runs on the PC, and
Yeah, like PCs, for some reason, they, at least using usual kinds of operating systems, they never can properly just like update something on a regular basis. At some point, it will just
Right.
like drop a frame or something.
The control loop
This
within
is
the
completely
video.
impossible to fix within the framework because it's not designed for
Yeah.
that. It's designed to run Microsoft Excel or
Within
whatever.
the control loop of a flight simulator, within the control loop of a flight simulator, where you have the user controls and you have the action rendering on the screen and everything, that would also suffer these kinds of problems, even though it's not trying to send anything off the PC, right? Because those control loops are still subject to the same jitter for the same kind of reasons, right?
well, I think the simulation software can assign different priorities to different
Okay,
tasks. So it puts priority on the input controls and on the screen and audio output. But
Okay.
the external program suffers from this prioritization.
I see. So
But
there's another program that runs on the PC that somehow taps into the video game or the simulation, and it translates this into motion and then sends out commands over USB or status information over USB.
yes, exactly.
Okay, so it wasn't part of the original coding effort that made the simulation.
No, this software is called FlyPT Mover, and I can see if
I see. So it's like a whole nother chain of latencies that are outside of the central simulation.
yes, but it's not the main problem. The delays are usually very short. It's a matter of 2 or 3 milliseconds. You don't notice it really. It's just the way the motion for sim controller handles this. It just doesn't handle it at all.
Okay,
So
that's the ARM chip thing.
that's the ARM chip thing, yes. And well, I think I have done a really good job to avoid these problems with the jitter and latency.
Yeah.
So how can I explain this? There are different ways to handle motion control. You always have a command input, and you have some outputs that how the motor actually reacts. And in conventional systems, you always have a delay between them. If you imagine the sports car is the command input, that means your car is always following it, and you always have a delay or positioning error.
I see.
So the best case would be if you can keep up head-to-head. So in the best case, there's no delay between them. Of course, that's only working if the second car is fast enough to catch up.
Right.
But what's important, it's not sufficient to just look at the position of the other car. You also have to track the velocity. So the solution is not only to focus on one thing, but to have two variables, the position and the speed. So let's do a little bit of math here. And there's a simple case. For example, you want to move to a certain position. And of course, you can't simply limit the position variable, otherwise you would run into this. If you use hard clipping and simply limit the position variable, that would mean you would have to brake at an infinite acceleration.
Like a step function.
Yes, and that's of course not possible. And even if it was, it would cause damage to the mechanics or cause injuries.
Right.
So what you have to do is make an early decision here and slow down over a longer time. But this then would require some look ahead. You have to delay the output or look into the future. That's possible for the trajectory of a CNC machine because you have to program in advance and can look ahead. But it's not possible for a simulator. You can't foresee the future when there's some real input from the pilot. You don't know how he reacts in the future.
Right.
So this simple case with the looker ahead could be solved at least for the limiting action. There's a very simple equation you all know for accelerated motion. Its velocity as function of time is simply linear, and the distance traveled as function of time is a half acceleration times t squared. But you don't know the time. Your input is only the commanded position. So you have to transform the formula, and what you get is the velocity is the square root of the remaining distance multiplied by 2 times the acceleration. So this is a square root function.
Okay.
So what you see is an inverted or tilt parabola. And remember this case, you want to not only move to a certain position, but you want also to track the actual velocity as close as possible. So the formula is a bit more complicated, but not much. You simply have to shift this parabola. So if your command position and command velocity is not equal to 0, you have to shift the curve. So you can travel until your actual state hits the parabola, and then you slow down until you reach the aiming point. Well, in reality, it's not that simple because the aiming point is always moving, so you have always to shift that curve. And remember the car analogy. So if you fall behind with your actual position car, you have to catch up. So you have to increase the velocity. And while catching up, you can accelerate until the parabola here, and then go toward the aiming point. I don't want to go any further into the detail and show the source code or something. I just want to show a photograph of the debug output. This is the scope view of the debug output. I used Visual Studio Code and together with Peanut to display the output. And as you can see here, if the servos can move with the required speed, the red curve matches exactly the green curve and you see no difference. And if it moves too fast, you can see that the velocity here is limited and it takes a little bit of time to catch up. So I think I have skipped this one. There are some other features in the software. It also has to do with the homing after power-ups. So what it does, it slowly moves the whole rig and each X to the bottom position until it hits a switch at the bottom. Then the neutral position, while the simulator runs, is in the middle of the stroke. So before the actual simulation is started, it has to move to the middle position. And this is all controlled by a small state machine. And in the case of something goes wrong, for example, the user presses the emergency stop button or there's a power failure or something, it has to move down slowly. This can either be done in a controlled way when the servos are still powered. They, of course, can move down in a controlled way, but if somebody presses emergency stop, then all the power to the servos is cut out. And we have a pneumatical weight balance. I think you can see it here. There are some pneumatic cylinders in the middle, and when the servo motors are not powered, we slowly release the pressure in the pneumatic cylinder so the rig can move down safely. So we are close to the end. Let's talk about the benefits of the Propeller 2. Maybe the best thing about it is really fun programming it. And of course, I already knew it, and I don't like the ARM chips, so I selected the Propeller 2, of course, but there are some other reasons. I already mentioned easy coding because of the true parallel processing. And I want to repeat this again. I find it really amazing that the Propeller 2 can bitbang the Ethernet protocol. You can see here, we don't have a special chip for Ethernet. This is just I think it's called LAN 8720 or something. The Propeller generates directly the 100 megabit signal, and this is more or less connected directly to the RG45 jacket. You can also see that the layout is extremely simple. It's mainly a star connection. There are very little wires or crossing traces necessary. You can connect any function to any pin. and the graphical debugging was also very helpful. And yeah, I felt like I don't have to fight against the hardware and all the limitations of the peripherals built into some of the ARM chips. You always have to spend hours or even days selecting the right chip because you need this interface and that, and then you have to decide how much memory you need. And with the Propeller 2, it's just easy. Just take this chip and you don't have any problem, to summarize it. So yeah, now we can simply watch the video. I don't know, it doesn't seem to work in this view, so I started directly. So the plane is still on the ground. It's moving not very much, but the whole simulator is not really finished yet. There's a lot of gaps here where you can see the outside world. But for the demonstration, it's good because you can see the difference between the movement of the rig and the movement on the screen. Here's the ball spindle. And now he's making some turns, and you can see the horizon rolling, but the reference here outside stays level. So you can see the difference of the simulator moving and the horizon on the screen. And by the way, the instruments are not working yet, so it will be a little hard to land without a speedometer. So
Wow. I know from messing
yes,
around with X-Plane.
that's
that
it.
Awesome.
Thanks for watching.
That's super. And in X-Plane, you can configure it for all kinds of different atmospheric conditions too, which would really test your simulator
Yes.
response, like things you would not fly a Cessna in.
Yes, if you have turbulence, it really becomes like a roller coaster.
That's cool. And those are some really fancy ball screws that you had with that spider coupling on the motors.
You mean the couplings between the motor shaft and?
Yeah.
Yeah, that big ball.
Yeah,
They eat that 100 base T thing is really that could be really valuable to people using the P2. My friend here who rents some shop space, he is building like automation systems for big customers, and he's kind of moving to servo motors which speak like 100 base T. So you plug power to them, and then you put an Ethernet connection to it, and it does all of the, you know, voltage regulation and signal production at the point of load where the brushless motor is, which is often geared down or something. So it's nice to do that, because then you don't have these high currents traveling through long, expensive wires that are sending off all kinds of EMI that are disrupting, you know, sensory wiring elsewhere. So this,
yes, I have already tried them. In this spring, I made some experiments with EtherCAT.
EtherCAT, yes.
So yeah, so it's basically Ethernet connection directly at the motor. But unfortunately, I failed. I couldn't get it to run.
Well, the problem my friend's having is he's getting all this hardware kind of inexpensively from China, and it does not work as well as like the what's the expensive stuff that everybody uses? They make PLCs, and they make lots of servo systems.
Alan Bradley.
Yes, Alan Bradley. So the trouble with the Chinese stuff is it could work very well, but it just has like details in their software implementation that make it not as good as it could be. But I mean, they do have power going to the motor. They have all the load switching, you know, using super high conductive FETs and things to generate the signals to run the motor. It's just the software between the Ethernet and the motor controller is not what it could be. So he's struggling with.
And it has zero error handling. It works as long as you do exactly what's necessary, but if you made the slightest error, it just refuses to work.
Yes. Yeah, it was like it was designed to just sort of meet a very simple functional spec, and that was it. And so it can't hold torque on a steady load. There's a lot of things that like the Alan Bradley stuff could do that there's no reason physically this Chinese stuff couldn't do it, but it's like a big gap in implementation quality.
Yes.
And then there's nobody to get any help, any real help from, because it was all done in China, and they have sales reps here, but it's like, a big, you know, stretch to get anybody who worked on it to give any information.
This is
But
just
it is
sort of a problem
kind of
that
the
exists
future, I think.
everywhere. It's just absolutely awful. My house is full of electronics where like I'd love to just change one line in the firmware to like fix some sort of issue that I have. But no, that is not allowed. You're not allowed to do it. They don't give it to you. They don't.
No,
If you go to the customer support, they just tell you, I don't know. I just work here.
Way out of
Like,
their hands.
Like, what the fuck is this? This is it melts my brain. I
Yeah.
should stop doing that. Maybe
Any
someone
other
should like make it so that if you buy something, you have to actually get like the full documentation on it.
Or start making it yourself.
Problem is you
Yeah.
can't make everything yourself, right?
Right.
Like if I started making everything myself, even if I had the capability to do so, I wouldn't get to what I actually wanted to do.
Yeah.
Right?
You only get to pick and choose a small number of projects in your whole career, it feels like. So any other comments, questions for Nicolas before we let him go to bed?
It was amazing seeing the work you've done. Thank you for showing us.
Yeah, your presentation was super good. You explained all this translation of like real world motion into kind of the impulse stuff you have to settle for when you're doing something like you're doing.
Yeah, and your
It was
background.
probably a little too theoretical, but I hope you enjoyed it.
I understood it, and I'm not super savvy about that kind of stuff. It all made sense to me.
Well, thanks, Nicolas. Come back when you have more of this working to share, all those displays. Well, I think we went quiet. Okay, should we,
Um,
there you are. Thanks again.
Yeah, thank you, Nicholas.
thank you.
Well, shall we see if Kevin's here and he can show us what he's doing with Kevinbot? Are you around, Kevin?
Yep, I'm here. Can anyone hear me?
Sound good.
All right, so if anyone's new here, I've been working on a pretty large scale robot for the past few years. And I'm finally ready to start production on my P2 breakout board for it. Let me see if I can get that pulled up here. And can everyone see my screen?
Yep.
So I've been working on this board for the P2 that's got 32 servo outputs and just a bunch of different components that can be useful for just large scale robots or just robotics in general. So yeah, it's fully open source and I have everything up on GitHub if anyone wants to check it out.
Kevin, the latest post on OBEX from Terry Trapp is that a model and layout for that connector you're using for the P2 Edge.
Here, I think I created this one here myself because I looked on there. There's no version for the surface mount, but yeah, I looked at those models. And they were really nice.
Kevin, how come your little robot logo seems to only have one wheel?
I've that sort of just happened as a mistake with exporting the file, and I just never bothered to fix it.
I see.
Yeah, so it just stayed that way.
Maybe it's a pirate robot with a peg leg.
Right.
So yeah, I'm using PCA 9685s for the PWM control. They're really nice chips if you just want a lot of PWM over I2C. They do 12-bit.
So on the right side of the board, you've got all these servo connections. Is that
Yep.
right?
Yep, right here.
And then go around and tell us what all we're looking at. What connects to different things.
So on the side here, I've got the 5-volt input as well as two voltage meters that can go up to 33 volts. And then up here, I've got 5-volt LED controller for just the WS2812s or whatever smart pixels, as well as a bunch of one-wire outputs in I2C. And then I've got serial input for a coprocessor, as well as external reset button. Then on the bottom here, I've just got a bunch of I/O for most likely connecting the universal motor drivers that I'm gonna get in a few days.
Yeah, those sent out today to you, by the way.
Yeah, I just got that email a while ago.
So it looks like, yeah, you were, having followed you for a long time on this, you had been dealing with so many wires and different processors and different kinds of things that you probably hit the limit on how to put it all together.
Yeah,
And now you've got a natural progression towards a pluggable system here, finally.
yeah. I mean, it just got to the point where I just had to make something like this to keep everything together. And here's the back of it. So it's just a 2-layer board.
Oh, that's good.
Yeah,
Hey,
and
what is
he's-
that little? Oh, go ahead, Ken.
Yeah, he's completely documented this too, so people are free to use anything they want. It's documented with all the files on a website that I circulated in the email on Monday.
Yeah, I've been testing out this new fancy tool for documentation called WriterSide. I think it's pretty nice. Unfortunately, it's not open source, but seems to work great for something like this. I can't seem to find the documentation right now, but yeah, let me see if I can get it pulled up. Yeah, I've documented the entire board, and it's all up through a GitHub action that I just automatically goes up here. So yeah.
When you say you're gonna put that in production, does that mean you're ordering multiple of those?
Yes.
Kevin, what is that 4427?
Oh, that's for just I'm just using it to shift the logic level from 3.3 to 5. I've used them in the
Oh.
past. They seem to work great for what I'm doing with it. And I've also
Okay.
got, right next to it, I have one of the DS18B20s. Let me just put this link in the chat.
Are you still going to school?
Yep.
What level are you in now?
I'm a freshman in high school, so 9th grade.
Oh, this is impressive.
Thanks.
And just last year, before he started this particular school, they did away with their engineering technology program.
Yeah.
That would have meant a whole lot, but it would have been nice.
I think when I was in high school, I was like the only kid I knew of that was into electronics.
Yeah, it seems that way here too. So yeah, I'm excited to share the rest of Kevinbot once I have more for it on the I don't know when the next forums are gonna be, but I'd like to show some of the rest of the whole project. And this is just one small part of it.
Yeah.
Another one of those parts too, maybe we should talk about just for a little bit, are the brushless motors. So I believe you have used our BLDC driver source code and hardware probably more than most people, more than anybody maybe, with those
Yeah.
hoverboard motors. And it turned out, I think you had some faulty hardware. You had our Rev A boards, which we actually scrapped, and there's about 150 of them sitting in my office at Parallax. And I also blew up some P2 edges with that early version, and I don't know why. I just gave them back to Chip and the other guys that were doing the design, and then they made the changes, and we came out with a new version of the driver board. So I'm hoping you have better luck and success this time.
I mean, this thing.
And aside, I think from the version, the hardware issues that we had on the Rev A board, I think you may have had some power supply shortcomings, but we're trying to fix that too, right? With a big, heavy LiPo battery,
Yeah.
which I'll get over to you when you're ready for it.
Yeah, right now I've looked at the software a lot, and during testing, the software seems wonderful for driving those motors. It's just the Rev A hardware that seems to be giving me a ton of trouble. So yeah, I'm supposed to be getting those Rev B boards on Friday. Then I can test it and see how well it works.
And this will have still a Raspberry Pi and a P2.
Yes.
And just generally, like, you use the Raspberry Pi for, was it the video?
Yeah,
And
I'm right
the-
now. I have it set up with a XB to communicate to a PC to drive the robot around, do all the functions. And then going from that XP, I have a Pi that just manages everything, and then this just runs all the hardware. There's no software to do any of the advanced stuff. It just takes in commands, and it just does stuff with the hardware from that. So I've just got a Pi as the interface to this, to the serial port up there.
What baud rate do you communicate at?
I'm using almost a megabaud right now. I'm not sure the exact number, but yeah.
Probably 921 kilobits.
Yeah, that's what it is.
How many layer board is that, Kevin?
It's just a 2-layer board for now.
Okay.
That's what I'm hoping to keep it.
Do you have the tools to do the SMT assembly there too?
Yeah. This is one of my first SMD boards I'm gonna try and do. I mean, it's just so hard to get anything that's through hole nowadays. But
It's hard to
Yeah.
get anything that's what?
it's through hole.
Oh, through hole, yeah.
What program is this board you're showing us in?
I've been using KiCad for board design and schematics. It does almost everything as everyone else, and it's fully free and open source.
Nice. Huh. That looks just like how I'd write schematics.
Yeah, one thing that about it is that if you work on it like this, it's really hard to break all the components apart into different files, because you have to remove everything and then just basically start over with that whole subsystem, and the way it
Yeah.
interfaces with a totally separate file.
Yeah, using lots of labels makes it way easier to manage than putting wires everywhere.
Yeah.
So you're not old enough to drive, but you're old enough to design a car.
Yeah.
So you're just about ready to order this board and get the parts?
Yep, I'm planning on ordering the board sometime either this week or next week. So
And how difficult was it for you to learn KiCad? Was that a simple program?
yeah, it's reasonably simple. There's just a few pitfalls with it that you just don't have with many of the bigger name softwares, like especially with the PCB editor. But there's really simple workarounds to it. I think it works great, especially for being free.
Well, it looks good, and this is pretty exciting. Order a
Yeah.
copy of the board so you can make a mess soldering. I always have to do that.
All right, I think that's all I've got for now. Any questions?
It looks great.
Looks great. Have you already selected a battery?
Yeah, I'm going to be using a 18.4 volt LiPo for the motors, and then I'm currently using a 12 volt lead acid for everything else, but I might also make that LiPo in the future.
Pretty cool. I think as you progress here, there will be interest from us in getting one of those for whatever things we might be doing.
One question for Chip about the universal motor board. Does it support some sort of torque mode?
Torque mode. You mean this thing here?
Yes, yes.
Well, you have to generate the pulses that drive the gates to the NFETs. And your feedback is, let me think, there's a shunt resistor, like a 5 milliohm shunt resistor, I think right down in here. And you can make, and then I think there's like a 25x amplifier, so you could take that as an A to D into a pin to measure, overall current flow. And then you can also measure the voltages at the center taps. There's a divider for that. So you kind of have to write, this gives you like the raw switching capability, and then you can see the voltages on the 3 signals, or 4. This actually does 4 signals. You could run, a brushless DC and use 3/4 of it, or you could run 2 separate brush DC motors, in both directions with speed. But you have 4 channels here, so you can look at the voltage, which you'd want to do when you're not driving, right? You'd want to relax it and then look at what comes back. But then you have all this inductive phenomena that's creating a lot of AC effects. And then you can look at the shunt, the overall current consumption to ground. So
but I think there's already some software driver that's for velocity control or position control.
Yeah, Stephen Morocco worked on that, and I think he posted it to, it's probably on our OBEX, right?
It's in the OBEX with also links to the repo back at GitHub.
I'll include it in my email to you, Nicolas.
Okay, thanks.
And then if you have any questions, feel free to email me about it. Things like that.
But we never really did figure out there's something called FOC or FOV control. I forget what those things, field-oriented control. I think that's it, FOC, field-oriented control. So that's kind of a science we didn't really get into. We were just generating waves and then reading Hall effect, like a 3-bit Hall effect sensor coming back. So we did all of our motion control based on the Hall effect feedback, not really field-oriented control, which is kind of like, it's a technique that there's really not that much out there to read about. Maybe that's changed. There was some open source motor controller software that executed a field-oriented control loop, but you'd have to get into the code and look at what it was doing to understand. That was at least one open source project I remember, but there was no single really good web page that explained how to do it. But Erna on here, he has done a lot of that kind of work.
Yeah, he's a real expert in it. But position or velocity control is some kind of hard because you have separate PAD controls, nested loops. But I think torque controls should be the easiest because you only have to control the current. And
yes, you would hold a pattern on the 3 outputs and then go larger amplitude if you start to slip, and if you start to overshoot, go lower amplitude, or even reverse.
Yeah, I was just thinking about making a force feedback joystick for the flight simulator. So I don't care at all for the position. I just wanted to apply a certain torque to the motor.
I see. Yeah, you
Just
know,
an,
you could,
just an idea.
yeah, you could do that. You could use a couple, one for X and one for Y with some kind of mechanical slot thing so that the X controls one brushless or moves one brushless DC motor and the Y does another, kind of like a camera gimbal. So you could then monitor where the user is putting it and apply force feedback to them, right?
Yes.
Ken, we're on Rev D of this thing, right?
I think so.
We had to keep changing it because we had problems with there was some kind of like capture capacitor that would be switched to the NFET gates, and you could not protect the controller chip from over voltage. It had to be built into the chip. So we started off one that was good for -4 volts. We kept blowing those things out. Now we have one that's good for like -21 volts, and that's robust enough to survive bigger brushless motors that have larger EMF, larger kickback.
Okay, I think I have one of the older boards, but I don't need large currents. I think 4 or 5 amperes should be enough.
Yeah, yeah. Higher power motors kick back more inductive voltage, and it's hard. You have to have chips, driver chips that are able to survive that. And you cannot guard the chip on the outside because by doing that, you diminish its ability to switch the gate voltage to its, what's controlling the load. We went around and around. This thing was very expensive to develop because it went through so many iterations. Plus, we had problems. It was during COVID, and there were parts that suddenly weren't available, so we'd have to redesign it just so that we could get the parts that we needed to accomplish a job. And then there was
the motor driver chip went obsolete in the middle of it too.
problem that we kept incrementally addressing of the motor defects.
Okay, so thanks, Kevin. What else would we like to talk about? We have a bunch of people here who do productive things with their time, and we want to make use of it, and we could have Chip answer questions, or anybody could tell Chip what they need from him too. Unless it's an SD card driver. We already know about that.
Okay, so the revision A driver, 3-phase driver, I happen to have 3 of those. Is there information on the forum about what to avoid to keep from blowing mine up?
I don't know, Ken, did we ever put any kind of errata app? I mean, we
did. But I think probably the best thing to do is just let me replace them for you. So you're current.
And what's the latest rev? I have a B in my hand, but I know we're beyond B, right? Aren't we to like D or something?
I think so, yeah. I could check it. But
yeah, I mean, that thing's gonna work, Robert, unless you put a big motor on it with high voltage, high current switching. That's when you blow up the driver chip.
Okay, so I have some of the hoverboard motors, and I have the motors that came with them, the small 3-phase motors that came with this. It was like a bundled kit.
Yeah.
So those will probably be all right then.
Yeah.
Work together. Yeah.
Can't use them for a wheelchair motor.
Yeah, when you get into the bigger hub motor under like high speed and high torque, that's when things can go haywire with the weaker chips.
All right, that sounds okay.
this motion control stuff has been really tricky because, I mean, it's just a late thing that they have such low on resistance NFETs, or any kind of FET really. I think these are like a milliohm or half a milliohm with like, I don't know, 6 volts of bias, forward bias on the gate. It's really amazing. So, I mean, these things pass all the current out to the motor load. But when something goes wrong, these things really like burn up. Because you're dealing with super small packages, and there's a big fat traces that connect to these things. But when this stuff fails, it can be kind of catastrophic for the circuit.
That was one of the 3 fires I've had on my desk.
Yeah.
Let's see if I could find the video. It's pretty good.
I've let the smoke out on a few things.
Steven,
about
oh, go ahead, Kevin.
what about SD card driver? Or did Ken already talk about that?
I haven't mentioned anything about that.
No, we know one is needed badly. I've got to finish this tool revision before I can approach that. But I also know that some exist. I think I know Ada made one. And
I didn't really make one. I just kind of fixed one up to the point where it works. I think.
Okay, so it's
I
not
think
really
Ray has a better version of that. That's
Ray.
like,
That's whose name I was trying to remember. Yeah, Ray.
yeah, but he worked off of what I built, which was based off another thing, and it's like the endless thing. Also, if you're using Flexspin, you don't need anything. You just include libc as an object, and then you can get all your C library functions, which include mounting SD cards and then reading them using your usual file operations.
Okay.
This is surprisingly not terribly bloatware, but it does take up a little bit of RAM. But it's also good and generally works.
We just need a good chip version that's good for commercial release, not hobby releases.
So Skippy, after you have the structures done and then you guys wrap up the TypeScript compiler, this could be the next big project.
So, okay, Kevin R is saying that there seems to be only Rev A and B schematics on the website for the motor control board. And I have here a B, and this looks like what I remember the latest one being. I don't think this one's popped its cookies anywhere.
Yeah, I think it is B. I think we had some internal revisions too.
Because I think some subtle revisions are done. We're done where we didn't go up a letter. And so B is more like D.
Yeah. But after structures and the TypeScript compiler is pretty much wrapped up, then you can move over to this project.
Yes. Yeah, we could do USD. One thing that I already have mostly done is the USB interface. I mean, seems to me it would be in some ways almost more useful to have a USB stick driver, like this kind of memory. Because this is like more commutable between a PC and an embedded system. With a micro SD card, you got to have a little holder, and you've got to have all the apparatus to let you plug it into the PC, and then you got to peel it out and poke it into, in our case, the P2 Edge. But this is maybe closer to being realized because I have the USB 1.0 interface or 1.1 all coded, and these things will all talk 1.1.
I'll buy that.
You would? I wonder what John would say about that. Are you here, John? I saw John post something. Oh, wait. Yeah,
He's still
no,
here, but
John's
muted.
here. Let's see.
Oh, John still says wants a micro SD driver.
I know,
Uh,
yeah.
I mean, putting a USB on a board is more complicated than putting a micro SD on a board, isn't it?
Yeah, but when it
In a
comes
new
to
board,
like
yes.
handing a customer something to plug in, this is like super easy. You know, micro SD is like,
Our P2 edges have
Yeah, they're kind of fiddly, but you
SD
can.
socket.
I guess you
Yeah,
could
yeah.
do full
We
size
have
if you
a
wanted.
connector right here.
Right. So we want to deliver on that promise.
Right,
if
I
you
know.
if you want to go like on a customer sort of thing, you can just go with the full size one. That's kind of a good middle
Right.
ground. If
Well,
you
they
buy the
have,
micro
like-
SDs, they usually come with the little adapter piece, right?
Yeah, look here. Yeah, the micro SD plugs in. You can't see that little slot there. But then this is the bigger, the full size SD. So
You
micro
can
SD.
sometimes get the full size ones, just normally still mostly high end ones for like photography. But yeah,
Actually, look. Oh yeah, look. This has it. Here's the micro SD. Here's the mothership. Docking. Bing, there.
thinning out the soup. The big problem with the USB is that someone will try to like plug a hub in or something, and then it won't work unless you figure out which device is gonna respond.
Yeah.
Chip, with
Also,
your
the
way,
data rate is lower just on the USB 1.1.
Yeah.
It's like
Oh, it's
12
like
megabit,
12 megabits. Yes.
maybe. On the SD
Right.
card, I think. Oh, well, I don't know
I think
what
at
it's being driven at. On a good board, it can do like almost 50.
Chip,
Yeah.
And that's with the
happier
SPI
doing-
driver. There's a guy in the forum who's working on like doing the 4-bit quad driver that needs a different board layout, but that will probably do like, I don't know. I'm just saying 200 megabit just because I'm saying that.
But you mean if we had the proper protocol, which is proprietary?
Not really, if it's documented well enough. Just needs the quad hookup, and then it will and then the code is over.
Is much closer. That's the point. And Chip, you'll be happier doing it because the USB stuff involves the kinds of things you don't like.
Me?
Yeah, you like things that you know completely understand, like every bit timing and every aspect.
Well, yeah, but I mean, I got USB running, you know, I can talk to a USB device and check it in, but I kind of needed structures to be able to do that nicely. Otherwise, there were just too many variables.
John said he sent you a SPI-based micro SD adapter that works.
Did.
A month ago.
Yes. And it has, I think, a PFET to cycle the power on the card so you can get it into a known state.
Chip, I think it'd be pretty easy for you to polish up the micro SD driver, especially because Kai's version from P1 we kind of have that working on P2. So really, it's just the low level initialization and block reader that. Oh, it seems to work fine for me, but sometimes there's issues. But if that could be polished up, I think it'd be pretty good there.
Okay, say that again. The starting point is.
Well, so there's two parts of it, right? There's the low level block reader and initialization, right. And then there's the high level stuff where you open files and stuff like that.
Right.
For the high level stuff, what we have working is Kai's P1 driver.
Oh yeah.
I don't know if you remember that. Yeah, I think he was actually interning with you guys or something.
But, yeah, he called it FSRW or something, right?
No, that one was that's the other version. So anyway, with the version that's out there now, you can use that low level driver with either FSRW or Kai's file system. Was
Okay.
and yeah, I think it could use some polishing for sure, because I just get, for me personally, I just get stuff till it works and then I stop kind of. So
Yeah. Yeah.
I think
I
if
wonder.
we chip maybe a 2-day hackathon in Red Bluff, California, and we have Ada and Johnny Macom, and then we have John Hoffman standing by making some barbecue ribs or something, that we can get this done. We'll never have to talk about it again.
Oh yeah, we could do that. You up for that, Ada?
I don't know.
I'll buy the
I mean,
meat.
that sounds expensive.
Well, get your passport.
yeah, and the fat, you could actually, if I was going to do it over, I think if somebody's going to do it over, I think starting from the fat FS, that's like the most popular SD driver out there in C. But it's the first part of it, initializing and reading blocks, that's fairly straightforward. It's like, I don't know, it's not that much code at all. So I think that could be easily ported to whatever. And then if you use the Kai's upper level thing or FSRW or either one, I think you'd be all set.
Yeah, I
Yeah.
mean, you could
Do
really
you
just
know
go
about-
in and just take one of the spin drivers and like just get all the bugs out, and it'd be pretty good, I think.
It'd be really nice if we did have it in 2 layers though, like the low level block IO layer.
Oh, we already have that. It's sort of an artifact of porting things from the P1, because the block layer was always in assembly, and then the file system layer in spin. They don't mix on P1.
Yeah, well, I think we want to definitely keep it that way and have a nice
Well, I think the problem is then that
officially
the,
blessed block layer that we can use in FlexProp and other projects too.
I mean, the one that is in Flex spin right now is good, probably the best one.
It's not. It's really good. Evan's done a great job on it, and Chip may want to steal some of that code for the SPI communication, but it doesn't have a very clean interface. I'm actually going to try to work on that.
You mean the interface between the SD driver and the file system driver? I mean, that's just whatever, right?
Well, that's in C. I mean, if we wanted it in spin, we could use a similar API. I guess
Yeah, I
the
mean,
same API and just do it in spin.
Just make it spin. I mean, there isn't that much high level code in there, isn't there?
Not really. It's just a little bit tangled up right now.
Yeah, just translate
Well,
that into spin and you're good to go.
Are you guys familiar with like the API for the Flash file system that I wrote that Stephen kind of polished up and finished? Is that a sufficient feature set? Like, is that API rich enough to constitute like a final product for a USD driver, or is
No.
it like what mainly is missing? Subdirectories?
Yeah, you need like this directories, you need like file access times, maybe. Maybe someone needs that. I generally don't, but someone might need that. You might need I think there was some sort of issue. Eric probably knows it better because he wrote the VFS to Parallax FS adapter thing, right?
Yeah, I think it's mostly there. I think we do need the directory stuff. There's maybe 1 or 2 small things missing, but it's basically, it could be extended a little bit to make it work well on SD cards, I think.
Is there good, my audio is on.
To be fair, there's some
is there
wacky.
is-
Okay.
Yeah, is there any is there anything different between FSRW and FATFS in terms of API that makes one better over the other?
FATFS just has a gazillion users, and so it's been perfected. So that's the thing.
Which one?
The other thing about the
FATFS.
Okay.
Yeah, it's
The
written
other
in
thing
C.
about FATFS is that it has exFAT support, which I don't think anything else has.
Oh, okay.
Yeah.
So it gives
It's
you
not
wider
enabled by
compatibility.
default, but you can enable it if you want to, if you for some reason need it, because exFAT is kind of a suck.
Yeah,
And
we're
it's
talking
got stuff
about
like
SD cards though, so is that going to be micro SD? Is that going to be important to have the extra support?
maybe
Yes, because
eventually.
if you buy an SD card that's 64 gigabytes or larger, maybe.
Gotcha,
Yeah, I think
okay.
64 gigabytes or larger, then it will be pre-formatted with exFAT, and reformatting it on Windows is kind of a ball-busting endeavor. Let's just
Okay.
say.
Yeah, thanks for catching me up. I hadn't thought about that.
But the problem is, if you do implement exFAT, it's kind of like very complicated, and doesn't really work as well as the original. The only thing that exFAT really does is it, oh wow, you can have a file larger than 4 gigabytes, or was it 2 gigabytes? There's a file size limit on FAT32.
Is it all allocation sizes or is it block size changes? Allocation.
It's about the byte size of the file. FAT32 stores it in a 32-bit integer, and file too big doesn't work.
Right.
There's no space. And there's another limit on the size of the actual disk, but that's not really it's not really a problem, because for 512 sectors, it's for 512 byte sectors, it would be like 2 terabytes, and I think that's only actually the file system itself might even be able to go bigger, because it only needs cluster numbers, right? I think
Yeah,
that's
that's why I was asking, is the allocation table inside
I
the
think
structures?
there's a problem somewhere. It's basically it's just being kind of it's just kind of up in the air how big you can make it, but realistically on normal size SD cards, it's just fine.
Yeah.
And the good thing actually about FAT32 is that you don't have to engage with the whole refat side of things, which is what enables long file names. You can just use the DOS style file names, which will reduce the code size and also make it easier to store like lists of files, because instead of having to potentially have a variable length file name, you just know how big the file name is going to be.
Yeah.
So you can store it in like your 12 bytes or whatever.
So
Yeah, that's
I'm
what
pause the
I
recording,
just
stop the recording, and I gave host over to Chip, just FYI.
Okay.
Thank you. You guys carry
I
on.
was just gonna say that so for what's there now for using Prop Tool, there's a simple version that's FSRW from P1 that's kind of been ported over and kind of made to work, and that just does the DOS style file names, and it doesn't have any directory support. But the Kai one does directories and long file names. I'm pretty sure that's true, and so it's a much bigger code, but they both work with the same low level block driver. And right now, the low level block driver can be either an assembly runs in a cog if you need speed, or it could just be spin if you don't care about speed.
Oh, that's another thing. The one that's used in Flexspin, the block driver, it doesn't use a cog. It just runs an inline assembly whenever it's needed. But that means it can't do background operations, and sometimes it doesn't work if you do it on multiple cogs, or maybe it never works. It's a bit weird. Just use it from the main cog and don't question it. It has been my approach here. But the other thing that I wanted to say way earlier about the interface is that even the VFS interface that's sort of like based on the C API sort of misses some features. And that goes back to the short file names and long file names. There's a way in the raw FATFS API to grab the short file name and the long file name of a file, because a file has both names in VFAT. And that's sort of like a very FAT specific operation that you might need. And that sounds very strange, right? But let's say you have one program that supports long file names, one program that doesn't, and you have to sort of send a path over to the one that doesn't support long file names. In one direction, it always works, because if you try to open a file by its short name, it works even if long file names are supported. But in the other direction, it obviously doesn't. So you have to figure out from the long file name, the short file name, which the API normally will do with like a stat or whatever it was. But that doesn't really have any standardized way to get it out. The other thing was about pre-allocating files to make them so they're linear in memory, which exists in R before, but I don't know, it doesn't get plumbed through. There's a way to get at those with like some evil structure indirection hack. But ideally, you'd have that sort of thing available. And then, of course, the flip side of making the file linear is checking that it's linear and getting the address, which is important if you want to do random access on the file. Like, oh, I want this part, I want this part, I want this part. Because if you do it using the normal FAT approach, it will just not work very well. So what you need is you have to, at the beginning, check, is the file linear? If not, I don't know, explode and tell the user to defragment the card. And if not, then we return the first block of the file. Because if it is linear, then it's just block of the file, block of the file, block of the file. There's no like data in between. So you can just say, I want this offset, and you get that offset. And that's sort of a very useful thing, because otherwise it would be very slow to do seeking between those locations. Oh, that was a lot, right?
Yeah, one other thing, you know, in terms of like polishing it better, is something I have in there. The version that I have on the forum there, it has something. If you freshly format a file and then put a giant file onto it, it's going to be in sequential blocks. And in that case, you can read it very quickly using the sequential block command, and that's kind of a hack, but it's kind of useful in certain occasions.
Yeah, that's exactly it. I usually just write code to check that that's actually the case. Because if you just click the defragment button on your Windows GUI or whatever, it will fix it. It will just fix that error. But generally, it never happens, actually. If there's any free space that's big enough, it will actually use that, at least on Windows and on Linux. That's been my experience. It only doesn't happen if you have a file that already has some blocks allocated, and then there's another file after it. It will try to reuse those blocks and then find the new blocks if you put in a bigger file somewhere else. So that's when you get fragmented files. Well, again, you can avoid it if you're writing it yourself, if you just find one big contiguous block.
You know, it's funny. What if you just opened up one gigantic file and then used that as like a virtual subsystem within a file, and you forever just dealt with that?
You mean like one big file and then there's all the stuff in there?
Yeah.
Yeah, I've done that a lot of times actually on the P1, because like that's the whole code SD streaming thing. I think the XMM compiler also did a similar thing. But basically you can just like loop all your data into a big file and just read it randomly like it's RAM.
Yeah, you could. You don't even have to use FAT on the SD card. But the thing is, the beauty of the SD card is you can just take it out and stick it in a computer and read all the files.
Yeah, and that's where you get with the big file. If you have a big file that you just sort of use as your little area where everything's inside, then you can copy that file around and it will generally stay contiguous. And by that, you have a very useful system that you can sort of introspect and and do things with on the computer.
But I'm not gonna ask my customers to take a SD card out and put it in a computer. I need it to be able to be read on the device. So I need a USD driver that is SRW friendly.
Right.
Yeah, of course, that's even easier, because if you're writing onto the thing itself, you're fully in control, right?
Yes, but control in the shop is different than control that in products that are released. I have over 3,000 P1 laser tag equipment out there and trying to port it to P2. We need a USD driver for P2.
I mean, if you're already using FSRW, then you can just use the ported version of FSRW. It's literally the same thing. Like, that's the least amount of breakage that's going to happen if you're just using the same thing, right?
Joshua, you're working. Oh, I'm sorry, I didn't mean to interrupt you, Ada.
No, I was done.
Joshua, you're working with John Williams, right?
Correct.
So, okay, so you need, explain again what you do want and what you don't want. I think I understood. You need an FSRW compatible SD card. So you want to send your customer a micro SD card in this format that he can plug into your system that he has. Is that
We
right?
already do that on the P1. What we need is the same USD driver available on a P2. John McPhalen can speak to that more directly and probably offline, not on this call.
Yeah, okay. Yeah, well, John and I have talked about that a lot. Okay. I got it.
So there's, I guess, another option there. So where the P2 can act as a mass storage device and, be connected directly to the computer. So like recently, like, Chris posted some code that does that.
Yeah, so
so I was trying that out or so, and then and mostly it worked okay, but of course then the SD card driver doesn't work. So I kind of just hacked it to use a little bit of a hub RAM just to see if it worked, and it did.
okay, this is like using USB, right? And looking like a mass storage device to the host system, or mass storage class device to the host.
Yeah.
Okay. So we need a USD that is FSRW work-alike for P2.
And Evan H on the forums has done a lot of work on low-level disk access, like using smart pins or bit banging. He's tried all sorts of different variations on getting the data to and from the SD.
Who on the forums did this?
Evan H.
Oh, Evan H. Evan Hillier.
Yeah.
Okay. Got it. Okay.
So he's a great resource. He really knows what's going on there.
He's he always takes kind of a first principles approach to things. All right. So I understand this is needed. I don't know how soon personally I've got to finish this tool revision, and then I could work on this. But I mean, it's possible that someone on the forum, you know, could come up with something that would be sufficient. What else is on people's minds?
Well, I and Roger, we have been working on HDMI audio.
Oh, good. Packing the audio packets into the HDMI stream.
Yes, we've got all of that working, but for some reason, Roger's TV specifically is like, I don't know, it's like old and cranky and doesn't want it. We through like it must have been like a week of like trying different things. We eventually figured out that you need to set a particular value in the channel status, which is like an utterly cursed concept to begin with. So channel status is something that originates with SPDIF interface, you know, the like optical thing, where like with every sample it sends 1 bit of that status word, and that status word is 192 bits long, and it contains some data of dubious veracity. And through like excessive trial and error, we eventually figured out that you need to set that his stuff needs, for some reason, needs the sample length to be set.
Yeah, that's so it's like a periodic or one-time message that if it's not there, it's not going to work. But you'd almost need like a HDMI analyzer to capture.
Yeah, he basically built an HDMI analyzer.
Okay.
Yeah, he built one just from like random scrap parts.
Wow.
It's great. So we eventually figured out that that's the trick to getting anything at all. Like we were stuck. Like it works on all of my stuff, which is a sample size of 2, and it doesn't work on any of his stuff, which is also a sample size of 2. And so we figured out that you have to set the sample length, which basically tells the device, okay, this is 16-bit, this is 24-bit, whatever, right?
Right.
Which I don't know why that needs to be a thing. You can kind of just assume that it's 20-bit by default, because there's 24 data bits, but the last 4 weren't originally defined to be data bits. So 20 is just a safe assumption, right? And it doesn't really matter because they're all left aligned. So even if you only take the top 16 bits, it will still work, right? You just get less precision. Strange that it is, but you need to set something in that field, otherwise there will be nothing, no audio. Now
getting that HDMI audio working is really a great accomplishment. Congratulations, that's pretty awesome.
Did it work for you? Did it work for you on your stuff? I don't remember.
Oh yeah, it works. It worked for me perfectly. Yeah. So it's
okay. So
it always did. Roger's TV is just. I think it's like ancient. It's like the first HDMI TV. I think it's
basically yes. He's got like this equipment that's of like a very particular age, where it has HDMI, but like ye old HDMI, where they didn't figure out how to make it work properly, I guess. Which is kind of strange. Like they have compliance tests for this. How did this happen?
Yeah, good question.
Anyways, we have figured it out, but now there's another problem, which is that it doesn't like the signal that my resampling algorithm puts out. Because if you've got some sort of audio generating code on the P2 itself that's just outputting to the DAX, it can run at any rate, right? You can do as many samples as you want into those DAX. But on HDMI, you kind of have to do either 32, 44.1, or 48. You can also do like higher rates, but they're not guaranteed to work. You'd have to like probe the EDIT for that. But 32, 44.1, and 48 should work, except they don't when the resampler is outputting them. and we don't know why. I'm pretty sure the actual output rate is correct. And I'm pretty sure that really it shouldn't matter how much jitter it's getting. I'd have to maybe run a bit more thinking on that. Or maybe check or maybe ask Roger for a new log of the current version. But basically the fun nonsense that we're into is that the Neo Geo emulator, which I'm using as a test for this, has like 55 point something kilohertz sample rate. So it has to like basically drop every 7th sample. Except that would suck, right? And so it has to like calculate in between samples. But that's kind of not really relevant to the problem. Because effectively what's happening is that every 7th sample gets skipped. It just computes in between ones in some way. And that should, and I say every 7th, it's not exactly every 7th, it's like uses some differential nonsense to figure it out when to drop them. And it appears that sort of inconsistency in the arrival times. So instead of having 6 samples arriving at equal spaces, you have 6 samples, then a gap, and another 6 samples. That somehow messes it up, which is how does that happen? Because the sample timings are already quantized to scan lines, because we can only send it during the blanking area, right? And the real HDMI hardware could send it any time during blanking, but we just send it during HSync because it's easy. I don't know how this messes up the audio buffers. Maybe there's some other oddity that we're not aware of. But right now the status quo is it works on most things just flawlessly. It works on Roger's weird thing. If you make sure that it's that you're not resampling in the driver. And if you do resample in the driver, it just cuts out every couple of seconds. Bizarre, right? And do we have some odds and ends to show off that? No, we don't. I mean, oh god, where's my video capture? Computer explosion in 3 seconds. When I start the video capture from nothing, because
You mean computers being absolutely normal?
no, I've had some just interesting things happen with the Vision RGB driver.
That's what I mean. They're always
Currently,
doing
I'm on the old version that I hacked to work with the new kernel, because the official version that they released that works with the new kernel seems to like hang the computer sometimes. And I told them that, and they said, your card is too old. We can't give support for that anymore. It's from 2009, you fucking imbecile. That's like newer than the 9/11 attacks or whatever. I don't know what's a good hyperbole to put there, but like, come on. Also, it's like literally the same as the new card. New card has the same hardware on it. like what it's just I did so at some point order a newer Vision RGB card because I found one for cheap. I don't know, maybe DHL will shake me down at the door again. Maybe then it's not so cheap anymore. They do that, right? Like they just ring at your door and like, hey, pay us money or we'll take your package back. Like you won't get your package if you don't pay money right now with the guy at the door. That's just, I love that. And they keep doing it. Anyways, maybe then getting a new card will fix the issue. Or maybe it won't, but then then the customer service guy has to listen to me. because it's the supported card that's still manufactured. Also, there's 2 inputs, which is perhaps relevant to something. Mostly relevant to me not having to climb under the table, so I have to plug between the VGA and the HDMI input, which is kind of, you know. Anyways, I've been stalling because I have to figure this out. And I'll show you some, and then realize that what I'm going to show you is incredibly stupid and uninteresting. Have fun. This truly is no signal. You good there, buddy? You good there? Did the device move to a different channel again? Nobody knows. This is just nasty. It should be at def video 0, but it is not. Oh no, the VGA is plugged in again. What I was just talking about. Finally, world peace has been achieved and we are displaying color bars. This is completely pointless because this doesn't do audio. Just imagine the sound. Just imagine there being sound.
But how do we know it's working then?
Well, for one, by the fact that the video is coming through at all. Because if there's certain kinds of bugs in the audio code,
Oh wow.
it will mess up the video sync.
Isn't that entertaining?
But that stuff has been ironed out long ago. Of course we can, as usual, demonstrate that we can in fact if we type numbers in. The emulator. I'm using this as the thing because it's like a real thing that you can actually get some use out of. I also have the color bars, and I have the heptaphone player, where heptaphone is a custom audio codec that I developed at some point, because I don't know, I do these things. I just make things like that, you know. And I haven't done it with the other emulators yet because this isn't working it properly yet. And the other emulators have more complex video output. The Neo Geo emulator is easy because there's no different video modes. It just kind of does the 320 by 224. It just does that. No, nothing else ever. And yeah, this is videos game. Unbelievable. No one has ever seen such things. But yeah, that's been my personal hell, trying to remote debug this HDMI driving issue. If someone wants to try this out at home, it is actually on a special branch, on 2 special branches, believe it or not. if we go to our GitHub, there are two special branches. It's also very special branches. They're called Video Next Gen, and also the other one is called HDMI clock regen test, which has been sufficiently put into the chat now. The clock regen test is the one that's probably gonna be the one. The difference is that the basic Video Next Gen branch, it sends the clock regeneration packet, which tells the sync the sort of fractional relationship between the HDMI clock for the TMDS and the audio clock. It sends that once per frame, whereas the other one, it actually follows the spec a little bit more closely and sends it like once whenever it needs to be sent. There's like a formula for this. But I've simplified it to just, okay, every 50 samples is going to be okay. And then it sends those regen packets and, well, it's audio, right? And that was another thing. But yeah, exactly, the clock regen test does it once every 50 samples, which apparently also contributes to making it work. Like, we've backported the channel status bit to the basic one, and that didn't make it work. Eventually this will work. Like, generally. It works on everything I have, so like I can't debug it, which makes it very annoying. Maybe I should buy ancient TVs and put them in my house. Wouldn't that be silly? Oh wait, I already do that. I mean, I really do. We've seen it before. The TV, where's the TV? Oh. Welcome to television. Television? Why is it still sharing the screen? No. No. Oh, it's trying to pick up the video capture as a camera. Stop. Stop. No. No, you're gonna crash it. Huh. Anyways, TV. But this does not have HDMI. Would you think it's funny if I told you that I have like 4 more of these? Not this exact one, but like I collect them for no particular reason. I just like having my living space full of TVs. If you remember back to when I did the Tempest port, that taught us a valuable life lesson, which is that television is the retina of the mind's eye. Yeah, I'm going mental right now. If someone has like an actual sensible topic, they can bring it. This isn't it. This is just me rambling, but TV. Unfortunately, none of these TVs that I collect have HDMI. So I'm limited to this like Asus whatever monitor. And the upstairs TV, which is upstairs. And therefore annoying to get to. I don't know where I was going with that. Please interrupt me. I want to stop talking. I want to get picked up. No, seriously, if there's an actual topic, I will shut the fuck up. I'm just saying things to fill the dead air, right? Anyways, television. Believe in the power of television, and also of shrine maidens riding on turtles. I think these two things are very powerful together. And I'm not just saying that because it's nonsense.
Chip, I have a question for you.
Finally.
Chip still there?
No, I think he fell asleep or something.
He walked away for a minute. We have an empty chip chair.
Okay.
No, he just I saw him fall over and he's just on the floor sleeping. But my nonsense was too boring.
No, you didn't.
Yeah, I posted a question in the chat, and I was just wondering if Chip had a chance to look at it or not.
What's the question?
Discussion we had several months ago. I couldn't even tell you when. But the concept was on the debug is a way to turn it off, say without turning it off for the entire routine, just turning it off for sections, like a debug on, debug off. I hadn't seen anything lately saying anything had happened with that. And I was wondering.
That went absolutely nowhere as far as I'm aware.
I'm thinking that it's not being worked on yet too. He's been really focused on structure.
In Flexspin, you can do debug disable on a per object level. You just define debug disable on the object. Oh yeah, we've got Steven here. He can add it into the new peanut. Yes, it's super simple. I'll try to find where the documentation is. Finally, where is it? Give it to me. No, where is it? Total spectrum. Whatever. Give it. Is it even documented, or is this just some figment of my imagination that exists?
I don't know that anyone documented desired behavior.
Is debug disable a real thing, or is it just something I imagined in my fever dreams?
Did you add that to Flexspin, you think?
That exists in Flexspin. I'm just saying that it's I'm just making a joke about having imagined it because it's not documented.
Oh, well,
okay, I can see the code. That's
gonna make it harder for me.
I can see the code. It's very stupid. If there's a constant called debug disable and it's not 0, you don't compile debug for that object.
Sounds like I really want a preprocessor directive, doesn't it?
No, it's you really don't want a preprocessor directive because you can't overwrite preprocessor directives per object.
If it were contained in a file, you couldn't you?
I don't know. It's a constant. I don't make the rules. Actually, I do, but
no, you're prevented not to. What do you mean? Chip, the discussion is, was anything done since the discussion of enabling debug per method or per object, since it was talked about?
No, I haven't done anything about that yet.
Okay.
Okay. The Flexspin, this is the documentation, I guess.
Thank you.
By documentation, I mean it's just 3 lines in the code that tell.
You're sneaky. So literally, const or default? What do you mean by default?
Const or default is just get me the value of the constant, or if it doesn't exist, the default value.
Okay, and you default it to 0 if it doesn't exist. Then you just check for 0. Okay, that makes good sense.
And this just happens when compiling a debug statement, and current is the current module, which is an object. In Flexspin, they're called modules.
So you just put an escape as you're beginning to compile the debug, and just don't compile it if that exists.
Yeah, exactly. It's
curious. I'm looking at the link that Ada posted, Chip, and it's basically some C code that's doing the disable by object in Flexspin.
Oh, okay.
That's a pretty trivial way to do it. We could both implement that pretty easily. So all you do is disable debug is equal to 1 or equal to 0 in a con section.
Exactly.
Oh, yeah.
It's kind of curious, but easy to do.
I mean, there's a bunch of other debug related stuffs that you can define in con, so it's not like
Yeah, it's not entirely terrible, is it?
Yeah. I was looking at it for a little bit more narrow, where I can debug it
Yeah,
for
we got
some
that,
a
but
code routine versus the entire thing.
yeah, we got that, but this is like
It's a different
50%
animal.
is good, let's say, right?
Yeah, that's a different animal for implementation. On a
Yes.
file boundary, that's pretty easy.
I mean, how would you do it for assembly? For spin, it's easy to just disable it on a per method level, but then you'd maybe have a lot of methods, so you'd
For
have to
assembly,
group
you
them
probably
somehow.
disable it for the DAT section.
Yeah, but you often have a lot of different things in the DAT section, I feel, just
Yes,
because
that's
they have to
true.
cross-reference.
It's true. That would cause you to have to reshape code for that to work well.
Quite honestly, you can probably just do it with preprocessor, right? You just
I could do it.
I mean, you can just do that with the existing. No, you can do, if you want to enable specific debugs, not just the whole debug, you can do it with the preprocessor by just guarding the debugs that you want to enable or disable with the preprocessor.
Yes,
yeah, with an ifdef.
And put a define at the top of the file. Agreed. And that would be
the thing with the debug disable is that you don't have to change anything about the command line or the object. You can just say, I want this object to have debugging, because normally what you do is define it as 1 in the actual object.
Yes.
But then in the little test harness, you'd override it to 0.
Oh, sneaky. Yeah, that's a good point. You can use the object overrides to set to turn off debug on things. Interesting. So
yeah, that's the whole thing that you can do with that. You can see that in action with USB new. Where's USB new? Give me USB new. I need USB new to show how that looks like. Is this in here? Is this somewhere else?
This whole command.
Oh, we have it. So here's just the USB new repository for perusal. Now this has a problem, which is that it won't work on the current anything peanut. Because it uses a feature another feature that's currently Flexspin exclusive, which is maybe I should open this up properly and show it up. So maybe I can impress the need as to this being added somewhere else. Wait, where is it? Here. Let us peruse into the land of no, that's not even correct grammar. Let us go into the land. Don't try to make it complicated. Into the land of USB new. So this is the USB driver TM. It has many features of various usefulness.
Yes.
And what you would do is you have a bunch of constants that you would change. And we have this conditional assembly feature in Flexspin that lets me do this based on a constant, notably not a preprocessor symbol, a constant. There's a big difference here. It's basically if half mark. We can make it bigger. We can see it. I said make it bigger. So why does this not go away?
Yeah, you have conditional assembly where that would be a preprocessor for us.
The thing is, this is not a preprocessor. This is this runs after the constants are calculated.
Ah, yeah, okay.
So and the reason this is like that is so you can have for one object overrides, but you can also do something more complicated with it if I can find it.
Yeah, but you have that. You have essentially you've redefined if for spin and if for assembly.
Yeah, exactly. If in assembly means nothing, it's a syntax error.
Right.
So
So then you've overridden it and given it feature now.
yeah, it's end I think also exists as a keyword already for org end.
Or assembly, it does.
So this doesn't cause any syntax ambiguity. It just
well, the end would, wouldn't it?
The what?
The
no, the
end?
end doesn't mean anything in assembly, but as peanut is any keyword anywhere where it doesn't belong is a syntax error. Flexspin actually doesn't have this issue. You can have a function called add, for example. In peanut you can't because add is an instruction.
Right.
So
in
Flexspin it actually does create some ambiguity.
Right. So end is used in inline assembly.
Yes, end is used for inline assembly, but we're using it here for the if end block because
I got you.
I guess end can never be part of assembly because then it would have issues with the inline assembly and the normal assembly parser.
Correct.
Being slightly different. So yeah, this just is so the only error introduced here is that if can't be a label anymore, but it couldn't have been already in peanut because it doesn't like having labels that are actually, you don't want labels that are spin keywords anyways, because you can use the labels in spin code as a memory address.
Correct.
So it's perfect. Where is that? Is this an old version that didn't update? That doesn't have the thing that I wanted to show.
Come on in.
Also protocol. Come on. Here's it. Here's the one I wanted to show. It has an underscore here because it's complicated. So this is the hit decode function. This is long, very long.
Mm-hmm.
And this is guarded by a big if here, which is underscore have gamepad or underscore mouse or not underscore mouseful protocol.
So you're allowing nested assembly ifs as well.
Oh yeah, they're nested as well. Yeah.
Yeah. Okay, that's not at all challenging.
The thing that this is this decodes a full hit report according to the descriptor. You need this if you want gamepads because they don't have a standard format, and if you want to use the native protocol of a mouse. You don't need it if you want the basic protocol of a mouse or a keyboard. Well, the basic protocol of a keyboard, but there are very few keyboards that do anything else. So it isn't implemented for that. This underscore have gamepad, of course, is also a computed constant because there's two ways to read the gamepad, and if either of them is enabled, you need the gamepad logic. So if you either have the gamepad or the full protocol mouse, then this gets enabled, and if not, it gets disabled. And why is this important? Because this is a lot of code, and you don't want to have bloat that you're not using in your binary, right?
Sure, of course.
And that's what this if end stuff does basically. There's also else. You can do else with this if I can find one. Yeah, there's an else. I guess else if also works. Do we have one? We don't have an else if, but just imagine it works, right? Probably if not and else if not as well, but I'm not sure if that actually works in Flexspin, but it should work. There's no reason for it not to work. And yeah, it's just like the spin conditionals, except there's an end. Groundbreaking. But I hope I impressed the need of this and its sort of orthogonality from the preprocessor.
Yeah, I can see why you do it.
Because preprocessor can do anything, any text, whereas this can only do assembly, but it's more powerful. It's kind of jank to have two systems, but the preprocessor really can't.
I was going to say, why do you say it's more powerful?
Because the preprocessor can only say if this or if not this, right? It doesn't.
So what you're saying is what you're saying is it's using compiled constants to check.
Yeah, this uses constants instead of preprocessor symbols.
And the only reason you do that is because
you can compute them and you can
do
override
object
them.
level overrides and affect what's compiled.
Yeah, the thing with this is you could do pretty much arbitrary computation in this if. Like you can use all the math functions that are allowed in a constant.
Yeah, I understand.
And you can also have
Well,
you could also use a constant that's coming from another object, right? Like I could say if something dot whatever größer equals 0, like that's a valid if statement. And so that's basically, it is a bit jank having both of them, the preprocessor and this. But I think there's a good reason for it to be like this. Partially just because the preprocessor already existed and just can't do this.
Yeah, we will keep that as a possible future, but that's a lot of work.
I don't remember how much work it was for Eric. I don't think it was a lot.
Well, it's essentially recreating all the logic of the preprocessor in context of the assembler. And so
well, you don't have to deal with the crazy comment stuff in this case.
Well, why not?
Well, because you should have already stripped the comments out earlier, like your parser should be ignoring comments.
Gotcha. Yes, of course they are.
Because this basically, the stuff inside the if, I think, still needs to be valid syntax. Like it can't just be invalid, I think. So really what you have to do is you have to know if you're in an active if section, and if yes, you omit the instruction, and if not, you just ignore it.
Yeah. And
that's where the nesting comes in.
Do you have that so that needs to be written up in spec in your documentation?
I'm not sure if this is documented either. There's a lot of this
that's what
stuff
I'm saying. We
I say, hey, this is cool, and I want this feature, and then this feature just gets added, and it exists, and
then the
documentation sort of lives. I mean,
the point is, the rest of us using your tools don't know about it because it hasn't been documented.
I mean, you can just look at what USB new does. That is.
Well, I'm not going to use that as a specification for sure.
That's of course not a specification, but that's like a.
That's where you.
That's what it's supposed to be, right? What's supposed to be correct.
Right, but that's what your documentation would do for us is provide the spec.
Yeah, I mean, the problem here is like it gets written up somewhere on the form, then it gets implemented, and then like maybe this is documented. I don't know. Let's find out together. Do we have a conditional expression? That's something else. Inline assembly, other inline assembly, different inline assembly, multi-assign, object pointer, structure, type parameter, unsigned operator, new operator. There's a lot of this stuff. Do we have conditional assembly in it? There we go. There's conditional assembly. It is documented.
Good.
Look at that. It's like 2 paragraphs. There isn't really anything to say about this. It just works like that, right? It just works like that. Okay, if not, apparently does not exist.
Did you find
but you can make it exist, I guess, if you want.
Here it is. Conditional assembly.
There's also the percentage sign syntax that Eric uses sometimes, which is sort of more, that specifically indicates like Flexspin, deep magic, voodoo stuff. You don't want to deal with that.
Right.
Anything with a percentage sign is evil, and and don't touch it. It's like the devil's fruit.
Don't replicate it. It's not good.
No, it's not that it's not good. It might do interesting things. Let's just say
Okay.
that.
Now, Ada, something you wanted me for, can we change subject just briefly? You wanted me to better highlight for Flexspin support the built-in underscore methods. Underscore built-in.
Oh, yeah, the underscore methods. Yeah, the built-in methods.
But I'm noticing you have new intrinsics that are also underscore that aren't prefixed with built-in.
Some exist, but they're like weird. Can you like show me one?
Just below the documentation you were showing me are new intrinsics for P1 and P2.
Where do we look at them? Oh, there's in this one, new intrinsics.
So that's kind of sneaky. So that's one set.
Oh yeah, those also exist, mostly because they don't exist in
Spin.
So the built-in functions, those are like C spec, right? Those are like sort of copied from C, even if they're like new ones like built-in MOV bits. These are basically just whatever instruction. These are basically things that are missing in Spin, these new intrinsics.
Okay.
Which is like Spin does not have a weight X
right.
equivalent function.
Yeah, I found that too. Let's see.
It even says that in Spin 2 mode, all of the above are available without the underscore.
Right.
Which I'm not sure if that even is true anymore. That might be outdated. That seems odd.
Yeah, it does.
Anyways.
But anyway, do you have a finite list of built-in stuff, or are you expecting me to just do underscore built-in underscore and allow it?
If you can do built-in underscore, you can allow it. If you underscore built-in, well, double underscore built-in. Let's just be precise.
Yes, please.
In general, anything that comes after that is gonna be some deep voodoo. So it's probably fine if the compiler just errors out if it doesn't exist.
Yeah,
but you can grab a list
I'm talking for the syntax highlighter.
You can just assume it's like a variadic function at worst, but because sometimes they get added for like new things.
So if Flexspin mode is turned on, then don't flag it as an unknown variable. Just assume
that's the easiest way. Anyways, you can find them somewhere. You can find all of the P2 specific ones. Some of these are these really? Yeah, there's a bunch of them. There's pretty much all the funny functions. Some of these are like super evil, like underscore in64 add, which I think is technically a valid function anyway. Or no, it's a private function. Or no, it's a public. The other function is also private. I don't get it. Some of these are sometimes in your scope, even though they never documented, which is very fun and kind of wacky. So maybe consider which ones of these are actually useful. That's kind of janky, yeah. It's kind of
unless I find them all somewhere, I can't.
I mean, you can find all the ones that start with built-in in this file, and you'd have a pretty good.
Okay.
I think this is all of them. Some of them might be in one of the common files. These are just the P2 specific ones.
Okay.
And you can see there's just a bunch of them. We have mostly just hardware instructions that don't exist.
Where are you looking?
In the file, you mean?
You're
like line 500 or something.
In MD?
No, that's the one that I just sent you. This is the one that lists all of them. That's really just the implementation of them.
Okay.
I don't think there exists a. Does there?
Document.
Let's see if it's. Let's type one in the search and see if it's
There's
documented.
only one
anywhere.
found in the document, and that's built in ALEC-A. And then there are some other underscore.
Oh, it's documented in the C part, but only some of them.
Oh, good. Sure.
Sure, great, man. That's
Sure. Okay. Anyway, that's a subject we can take.
Yeah, some of these are like no. There's all of them. There's all of them. You just have to scroll far enough down.
Where?
So the C documentation is the code that has all the built-ins listed,
So
even though they also work in Spin.
but I need to know what file it's in.
If I posted another one into the chat.
Oh, you did? Okay. Of course, I scrolled away from the chat. Where'd the chat go? There it is.
Wait, why am I linking to this in plain text mode? That's.
I don't know.
Why is it? Why is anything?
Plain text mode. Who knows? There we go. Lots of built-ins. Yeah. So basically, just assume they're all legitimate.
Yeah, that's possibly the least.
One.
Least. There we go. That's the real markdown link.
Thank you.
There's a couple of them that are wacky. Like you've got a cog start built in.
I see that just aren't, and I frankly I'm not sure I want to care about those.
Yeah, just assume it exists. That's basically what you want most of the time.
Yeah, I don't have a problem with the built-in ones. I'll do that.
Yeah, that's
it'll get red. It'll get the red things out of your face.
Yeah, let's actually see what kind of red things we've got left in like a random project. Oh, here's a funny one. Look, we found something that's nasty and evil. And by nasty and evil, I mean it's actually really good.
The things that are kicking my butt are people that try to comment out the line endings to do continued lines.
Do you mean the triple dot?
No. Triple dot's easy. It's the people that used the non-dot comments to hide the end of line, and then
oh yeah, that's like the
start the next line
before the triple dot was invented. This was the way.
Correct. Parsing that was
the way of the water.
Nightmare for me.
You go with the nature. You go with its flow, and that includes that. If nature is the original spin 1 compiler. I mean, the triple dot can be added to the compiler. It's not even a bytecode feature, so.
Yeah. No, triple dot's already in the extension. That's easy. I think the non-doc parsing.
Now here's a good question. Does the spin 1 mode in Flexspin support triple dot?
No.
Now that's a complete in Flexspin. I mean, Flexspin treats spin 1 and spin 2 very similarly. So sometimes things like that work, but again, it's probably not documented anywhere.
You're going to make my spin 1 support be a real headache.
When I go back to working on a spin 1 project, I will probably murder you or something. I don't know.
Yeah.
This is a death threat. This usually is death threat. Anyways, here's a red underline. Look at what great gifts I bring.
Yeah, that's just special. What are you doing with colons?
That's I don't know why it's a colon. It just is, but
what is it?
This is accessing a local label.
Oh no, cut it out.
So we have this local label here.
Is that Flexspin specific? Because I don't recognize that.
That's probably Flexspin specific.
Yeah, well,
maybe it also exists in somewhere else. I don't know, but this is basically we want this local label that exists under this global label.
This method, yeah, great. So you're referencing a local label in a global context. That's just mean.
I mean, that's actually very useful, I think.
Well,
because sometimes you just have you have a label like this that you don't want to have a global name. Because what we're really doing with this is we're just patching a value in there, right?
Of course. But then why are you accessing it remotely? It's just mean.
Because you don't want, this is like a super cycle counted routine, right? This has like 1, 2, 3, 4, 5 instructions.
Right.
We can't put it in here, and it doesn't belong in this like void down here, which is still sort of part of this label. But we want to set this in the startup code.
Oh yeah, so you're actually doing a patch, but patches would have required global labels, and so you figured out a way to do patching of local labels.
Yeah, you could make it the problem is if you make it a global label, then that invalidates any local labels that are above it. So if you have a patch in a long function, you can't use the local label in a loop or something like that, but it's really annoying.
Yes, yeah, I can see that. So patching can actually destroy your global local shape that you're trying to achieve. And so
Exactly,
you
and
created this override.
Exactly. This allows you to just grab the local label from the global label.
Yeah, understood. Chip, are you noticing this syntax? You're muted.
You're still muted.
Okay, sorry about that.
Take a look at this red underline stuff.
Yep.
This is assembly language code that's accessing a local label under a global label.
Yeah. We used to do that. I mean, I did that on earlier assemblers, but I kind of made a boo-boo years ago and used the period for local labels. I should have kept with the colon.
Yes.
But we could make our assembler work so that we say audio poll repo dot pptchs.
The spin2 assembler.
Yes.
Yep. What do you think?
Yeah, I think the reason it's a colon here is just because the feature was implemented in spin 1 and Eric just didn't
spin
think
1,
about
yep.
it when changing it. Because this is spin 2, right? But it has to be a colon because that's what it wants. I guess a dot would be better in this case.
It would be, because dots are local labels.
Yeah. Well, it used to be that colons made local labels.
Right. So, okay, cool. So that is actually a sensible thing that we could do then. Interesting. Let me screenshot that puppy. Got it.
You screenshot it with like a camera. Like, why does it make a camera sound when you make a screenshot?
I know. That's the Mac. Macs always do that.
No, now they're going
like
down.
You took a picture. I did.
Oh no.
Everything is a camera in Apple land, right?
I mean, the actual camera making that sound is one thing, but the screenshot making that sound is very odd.
It's just not to me, but I'm sure to outsiders, yes.
I feel like that's the sort of thing where I take like 5 trillion screenshots every day.
Yes.
I need a power plant just to power the screenshots on my computer, and
having new
it would be very annoying if it made sounds.
Yep, every time. Yep.
Anyways, that's
cool. Well, that's an interesting find. What's the other big redness down there?
That's that one. That's the only error in this HDMI driver
Chip, we're kind of exploring extension highlighting issues, because I have no clue about anything like that because it's not legitimate language spec.
Let's see,
in our world.
Do we have any errors in our big old assembly file? No.
So I'm getting slightly better for you.
Okay, so there's no error here, or it just like hung up and isn't loading. Could be either. Let's see. GameDB file. GameDB file is full of error. Mostly because this is an include file, and that's a kind of an issue that you have to think about when a preprocessor is involved.
Yes,
because this is using symbols that the preprocessor wants to define, like set char and load CROM, and those don't exist in this file. I have no idea how to properly solve this, quite honestly.
Well, if the only way we're going to be compatible is if your include file was also a spin2 file.
I mean, this is a spin2 file. It's just a spin2 file that contains mostly data.
No, I'm saying, is the file you're including also a spin2 file?
Yes, this is the file that that is being included.
Oh, okay. But then where's set bank switch coming from?
It's coming from the file that is including this file. Right? So let's go to upper and show how this looks on the outside.
Your include is expecting information from the context?
Yeah, this is include GameDB. That's the only reason this is an include is because putting it all in this file would be a giant mess. So this is the include file, and there's a bunch of constants such as set that are sort of relevant to the code, and they're defined somewhere like here. These are all the sort of opcodes that the script can use.
Yes.
And then in the GameDB file, it just defines every possible Neo Geo game, all of them.
In the highlighter,
almost.
If the highlighter was loading the include file correctly, that should have highlighted correctly. So something's wrong.
No, it's not because this file here it doesn't include anything. So if you just take this file alone, then these symbols just don't actually exist. These only exist because this file is included into the context of the upper file.
Oh.
Right?
Yeah, see, now I'm thinking in two different contexts. If I think about the compiler, that's all one file after includes.
Yeah, the compiler just does it.
Right.
It does it
So
great.
I wouldn't have a problem with compiling it, but
this is just an editor problem, yes.
Yeah, the extension is preloading includes only when they're encountered.
I mean, this is like a very
edge case
kind of thing.
Since you have it at the bottom of the list, it's not included at the time we're highlighting. Wow.
No, this file has no include at all. This is just this file. This file is included into the file that defines the constants.
Right, which in that case, they're going to be read because you're getting the symbols out of the include context. So
yeah,
there's no way I could highlight those correctly.
Yeah, I was saying that I don't have an idea how you would do this unless but then you don't know then if there's multiple files including this one, you don't know whose context to use. So
Correct. I literally have to scan all the files and know precisely.
I mean, this is a very niche sort of thing to do.
It is, thank you. Thank you for admitting that.
But yeah, maybe you could add like as a very editor specific thing. Maybe we have to put it into a comment, like or maybe like a pragma. We have pragma for this. Genau. So maybe pragma include from since spin2 is usually order independent, I don't think it matters necessarily which order everything goes.
Correct.
It's just you could have a pragma like this.
With a highlighter, it has to be preceding what I'm going to be highlighting.
Yeah, you can just you could maybe implement a pragma like this just for the highlighter.
Maybe.
Are you handling pragma at all?
Yeah, I already have highlighters. I already have highlighter specific directives. So that's not terribly out of scope.
Anyways, write that one down. It's kind of niche. And
I'll add that as a possible feature enhancement.
Yeah, just write it down. Let's see. Let's continue the journey through this one project. Okay, it can't find libc.
Yep, we won't.
Okay.
Do that. Yep.
I mean, this happens in like almost every program.
Yeah, but I can't do anything about those.
I think the thing is with that is that you can actually do something, because what libc is really is just let me find where this gremlinly file actually lives.
Is it a binary file?
No, it lives in Flexspin's include directory, which maybe it would do something different if I actually set that up as a library path, which I don't think I have for spin, because that's the only spin file in there.
Right.
And it looks like this. Look, it's a spin file. And then it includes, then it does this, yeah.
Anonymous one, yeah.
Notice the percentage sign.
Yep.
Anonymous is an undocumented.
Love that.
Wait, it's not undocumented, you just documented it.
Right there, but not in the source code.
It should be a doc comment though.
It really should be, yes.
Then it's legit. So this is a spin file actually. So you can grab the constants from it, I guess.
Yeah, see, I've got no way of knowing without pre-processing the entire file and evaluating the language. I can't tell if it's going to be spin or not. So I'm not going to put a recognizer in. If you give me the suffix, I'll know.
Yeah, what actually is in, oh yeah, the libc.a file, that's another one. That's actually just this. This actually has a list of all the functions in it.
The A file does? That shouldn't be a text file. It should be a binary library.
It should, but for some reason it works like this.
Oh, you guys.
I don't understand it either.
You're messing with the entire world by renaming what file types are.
Ask Eric why he does it like this, but there's a reason for this.
That's
and it's just, It's anyways, it's a list of all the functions.
All the methods of the C library. It makes sense.
Yeah, these are all the methods that you can call on libc, and maybe you can just like, how would you do this best? I don't.
That's too much work. I think I'll just let it be flagged.
I mean, you could just like put a list of valid functions in and like just grab all the functions out of this.
No, that's changing over time. I can't.
I mean, most of these don't. Most of these are just standard functions, like
Hold on, I got a call coming in.
Okay.
Hey guys, just want to say
Hey.
hello.
Harry, how you doing?
Man, I'm doing okay. I'm over here fighting some crosstalk and learning, and it's painful.
Crosstalk?
Yeah.
How so?
And for some reason, on this light controller, like I rebuilt the board, redesigned it so that I would have a 4-layer stack up with signal, ground plane, power, and signal, and put my slower signals on the power plane side and put my fast signals on the ground plane side. And man, I've got the same exact problem on I guess it's P 32 through P39, or 31 through 39, or something like that.
Okay, well, let's see, 32 through 39 is the last 8. It's the last set of 8. So that shares one common voltage regulator.
Uh-huh.
And those pins, if you're switching a bunch of pins in digital modes simultaneously, then that's causing some like local it's not happening, it's happening actually on the chip, and it will happen among sets of 4 pins, like 32 through 35, and then 32 through 35, and 36 through 39. You said it's from 32 up?
Yeah.
Yeah, so if you switch if you switch 3 of those pins at once within a group of 4, it causes such an instantaneous current draw that it changes the voltage, like the effective threshold voltage, by just for a few nanoseconds. It drags down the on-chip power rail or pulls the ground rail up, and it can cause like a misreading of a digital input. If you switch only like 1 or 2 at a time, it won't do that. And this really only happens if you're mixing inputs, if you have super strong outputs adjacent to inputs on the same 4 pins. It can cause the input to kind of like flip. It doesn't flip permanently, but it just glitches. But
that's exactly what I'm saying. Yeah, it's glitches.
Yeah, if you're just outputting, it doesn't matter, because everything is an output and there's nothing coming back digitally. So there's nothing to see there, it's just driving those pins. But what you can do, you can get rid of that immediately if you can use like a current mode or a resistor drive mode. If your system will, if the signaling, if that's sufficient for signaling whatever you're doing, because that cuts the peak current down to something totally manageable. It's like almost no change at all. So if you use a current mode or a resistor drive mode, you'll get rid of that glitchiness. So those
these are 8 contiguous outputs switching at 800 kilohertz, and I did change it to let me look at my code. I believe it is the 1K resistor output, but I may have changed it to something else.
Okay, well that'll cut the current draw way down so that
Yeah,
you don't have this problem.
Yeah, it cleaned it up on all of them except for the very last one, which is I guess it's P30, not 39, 39.
39, yeah.
And it's it's wild. I'll have to turn the camera around here just to show you what the effect is. Yeah, I'm using right pin 0000 C00. And whenever I do that, it fixes 7 of them, but my 8th one just gets crushed. And then if I change that output drive to like a 000080, it fixes that one, but then causes the other ones to not be happy.
Wait a minute, 8080. There's going to be 2 3-bit codes. One 3 bits determines your high drive, and the other 3 bits determines your low drive.
Okay. Oh, all right.
But honestly, you should probably just use the like predefined constants, which are like P low fast or something like that. That's the names.
Yeah.
Because doing it with the numbers, with the bit fields is like it's brain melting.
So I spent I don't know, about a half hour or so trying to find what those constants are. Were they defined?
In the spin 2 documentation document.
Okay, so it's in spin 2. Okay.
Well, yeah, they're defined there, but if you look at the silicon document, let me find that thing.
The silicon document doesn't have what they're called. It's kind of annoying.
Well, you can see the bit patterns in there anyway. Let me see. I'll go to my drive here and look up this document. Okay, what is it called? Let's see. Here we go. Parallax Propeller 2. Looks like this is it. Hold on. This is the silicon. Yeah, the Rev BC silicon. Rev B/C silicon. So if you go way down, I'll tell you what page it's on. Okay, hold on here. Okay, pin configuration modes. Okay. Wait, let's see. Oh, okay. On page 80.
Okay.
79 and 80. You'll see these the D20 bit 20 through 8. You'll see like HHHLLL. Those bits select low and high drive. Low and high drive modes. So
is this the hardware manual?
Yeah. Well, yeah. It's called Parallax Propeller 2 documentation V35 Rev B/C silicon. Let me pull a thing here. Oh my gosh. No, don't do that. Okay, here it is. I'm going back to small. Okay, now I'm going to go File. I'm going to say Share. Okay, I just want anyone with the link. Anyone with the link. Okay. Oh, and let me copy the link. Okay, now I'll put it on our chat here.
Okay.
All right. What? Right here. Hold on. Everyone. Is that it? Let me see. Hold on. That just looks strange to me. Let me go to the Parallax site.
Oh, it looks like Steven's back.
Oh, good. Let's see, where's the documentation? Hold on here. Okay, here we go. Okay, there should be a link. Okay, parallel, here we go. Okay, copy link address. Now let me paste it in here in case it's different. Okay. All right, that's a big looking link, but if you go in there and go to page 80,
Yeah, that's definitely different than the one that's listed as the hardware manual in the Propeller.
oh yeah, this is the one I work on. I always
Okay.
I always keep this thing updated whenever I, discover anything new or whatever.
This is where the knowledge lives. Actually, chip.
What?
I've got a great program that you need to run right now. It's so good. As you just said, let's see, does it have any things in it? I wonder if I can paste it in the chat and it will survive the formatting.
Try it out.
Find out.
So meanwhile, Terry, go to page 79 and 80.
Got it. Yeah.
Okay, so you see that chart there says right pin D bracket 20:8 configuration on 80?
Yep.
You see that okay, so the 0 mode is just regular output, right? Where the first four bits are 0, 0, 0, 0 underscore, then it says CIO H H H LLL.
Yep.
Okay, so you see those H H H and LLL bits. So go down to the table there where it shows the H H H and LLL. Then on the other column it says drive. Like it's in that same drawing, just down in that middle area. It's where we define the CIO.
Yeah. Okay. Yeah. It has like DAC or input or out.
It doesn't work like that. Sorry.
Yeah. So those HHH LLL bits, the first set of 3 bits specifies the high drive. The second 3 bits specifies the low drive. So if you just set like the high drive to something other, and you didn't affect the low drive also, then it's going to slam that pin low. And when it does that, it's going to lift the ground reference, even though it's like as fat of metal as I could make on the chip. It's going to jerk the ground reference upwards, just for a nanosecond or two when it's switching. Actually, it's like a quarter nanosecond, but it's enough to register a glitch. So what you want to do is change set HHH and LLL to something. So if either one of them is set to 0, 0, 0, that's fast mode. That's where it just slams it real quick. So if you put them both to 1.5K, you would do a right pin. Let's see, that's going to be D20 to 8. It would look like, what would that be in hex? It'd be 24, 2400. So $2400, or just percent. Well, you could just do this. Just look at the top line where it says 0000 underscore. Just do 0, 0, do a percent sign, right? When you do your right pin, a percent sign in front of the value, then 4 zeros, underscore, CIO. Those can all be 0. So 0, 0, 0. And then you want to set them both to 1.5K, then 001, 001, and then do an underscore, and then do 8 more zeros, because you got to just flesh out the bottom, 8 bits. Which just put zeros in those bits. So no smart pin mode.
Okay.
So that's going to give you like 1.5K drive for both high and low. You could do all 8 pins.
Oh.
And that's going to stop the slamming.
Okay, because right now, so I'm using C00, which just gives me out 1.5K.
let's see, C00. Okay, that's going to be, C is going to be, well, that's funny. The HHH is going to be 001 and the LLL is going to be 100. So it's going to be like 1.5K drive high, 1 milliamp drive low.
So that's probably what's getting me is the.
Well, those are both lower current modes. The fast
Okay.
one, it just switches so fast that just the sheer capacitance of the pin is the load. The internal pin is the capacitive load that is heavy enough that it winds up jerking the ground metal up or the VIO metal down voltage wise before it recovers. It's like it's shorting out a capacitor and it's just clamping the supply briefly.
Okay.
For like less than a nanosecond.
Is that visible if I look at the supply pin, which I'm not using? So it would be open. Can I see that on the supply pin?
No, because the voltage drop is occurring after the supply pin gets onto the chip. Because these are like super high. I mean, it's like several amps of current for, it's probably like a couple amps of current for like 200 picoseconds or 250 picoseconds. So you take that little tiny bit of wiring, and it's not very resistive, but under that many amps, it does drop voltage. It's like IR loss, IR drop, but it's just temporary.
Yeah, I didn't know if that would be visible on the VIO.
No, you wouldn't see it.
Yeah,
It's happening on the chip.
It's happening. Yeah, all right. Okay. Yeah, because I mean, looking at the output, I do see something unusual, and it looks like there are like these spikes. Like looking at it on the scope, it's like, okay, here are all my regular levels, and then here are these spikes that are coming like almost at a different level. It's like I see two different voltage levels on there.
Weird.
Yeah, and that could just be some artifact of my trashy scope too. So.
By doing a right pin C00, you were putting kind of a funny configuration. I mean, C, okay, the 00 is going to make bits 7 through 0, right? But the C is going to be 1100. So H would have been 001, and then LLL would have been 100. So it's kind of like a hybrid thing. You'd have 1.5K drive high, 1 milliamp drive low. But this may not be, I don't know, there might be some, there may be some other issue going on. But if you switch parallel outputs quickly, especially like a whole bunch, like 4 of them at once, like a group
of 8 of them. Yeah.
Then it's gonna create like a local, like it's gonna knock the local voltage rails down before they recover.
Okay.
And it's all gonna happen less than a nanosecond.
Yeah, I mean, to make matters worse, it's not like I'm driving those pins low at different times. I'm doing like, what is it, a set B, and then writing out all 8 of them at the same time. So
yeah.
So that I'm just making it worse by doing that. I was trying to save clocks.
Well, yeah, I mean, you could break it up into a couple of steps where you do, 3 or 4 at a time or whatever. Or you change the drive mode so that you don't have such a massive current draw. Because just the transistors that control the output drive, those present so much load. Like if you turn a P on and the N is off, well, the N is like a capacitor. It has to charge up the N FET because they're in kind of a totem pole, or vice versa. If you turn on the N FET, it has to charge the P FET. If the pin had been high. So there's just big current draws that are very short in duration, very high current.
Let's see here. All right, I got my camera on. I'll show you what the effect is. It's kind of funny. If I can get this going. Let's see here. So there's my board, and I'll just show you what. I don't know if you can you see that over there?
Yes.
So that is my talking, singing Christmas tree.
Oh,
And
it's a mouse. It's like a face.
yeah, so as I put my finger on the pin, hey, look at that, everything's great. Take my finger away, and all I'm doing is just touching the board.
Okay, well, in that case, it seems like you might have some open pin. Like, do you have a pin that's an input that could be getting wrong data? Because by touching it, you're just adding a little capacitance and maybe a little resistance to it.
Yeah. I don't think I don't know that any other cog is configured, on these.
Yep.
And I have, so here's the thing is, so I have, it's only affecting the very last output. So every one of these guys right here, they're divided. I have a cog that runs this, that drives an 8 set of pins, this that drives 8 set of pins, this that drives an 8 set of pins. This one is 0 through 7, and then this one is 8 through 16. And then between those guys, I chose like the worst pins to go to the Ethernet card, which is, 17 through 31 or 30 or 30,
Okay.
whatever it is. And then this is the next set of pins after that.
So that's
And
32.
yeah. And so this occupies 16 pins, and so this would be an out B. But apparently, I'm wondering if the way I'm doing my set B, if possibly that's what's causing this issue, because in the code, I basically, whenever I'm setting up that pin, I set all of those pins to drive low, and then I do my set B, and then I do an out A, but I'm giving it the value of pin 31, and I don't know if that's the only thing I could see that's weird. But I went through there and I moved that around so it would be an out B, same result. I don't think that's
Well,
doing
but
it.
you touch your finger to it and it starts working, right?
Yeah.
That means that tells me that there's some kind of floating input that is being influenced by those adjacent fast switching signals. And when you put your finger on, you're providing enough capacitance to stop it blowing in the wind so easily.
Yeah, and it's like, here's my Ethernet, and that makes absolutely no effect on this guy at all. Ethernet's ran on this side. There's a ground plane, a power plane between that and the backside.
But you just touch that part there.
Yeah,
and
I mean,
it straightens up.
Touching that straightens it up. Taking and just putting the scope probe on the thing. So if I put a scope probe on this guy,
yep,
it straightens it up.
Yeah, you're adding 10 puff. That's probably what your finger is introducing. So that makes differences not on outputs, but on inputs.
Okay.
So there's some kind of, something is an input there. You have some input, because an output doesn't care. It's going to drive whether it, gets rickety on the way up and down or not because of too many simultaneous switches. But an input is very susceptible to current induced or capacitive coupling.
Okay. Well, I don't know what would be an input.
Okay, well, what can you touch your probe to that makes it stop? What pin is that?
So the things that I can do to make it stop is I can touch the actual output of the pin. I can even just put a wire there. Problem solved.
And it is purely an output. It's never an input.
Never an input, and nothing near it's an input except for the previous set of pins below it. But this is the very top pin on the output, and nothing is next to it. So like pin 40 or whatever. None of that's used for anything.
So this is pin 32. What pin number is it exactly? Is it 32 or 39?
39 is the one I'm having trouble with.
And it's always an output.
Yeah.
And what does it look like on the scope? Can you show?
Yeah, so let me put some input there. If I can get this camera to go over. Man, can I bring the scope to me? I can't. give me a second and I'll get a camera over here.
Okay. You know, it could be, what if it's the pins on the other side of the connector, like directly across from 39? Let's see, what would be opposite 39?
So 39's kind of in a corner all by itself.
Oh yeah, it's all by itself. Oh yeah, that is, it's all by itself. And then opposite of that is a no connect. Okay, on the other side, well, that shouldn't matter. Yeah, 39 is all the way on the end, all by itself. Yet, just putting a scope probe on it changes other things. Huh.
Let's see. All right, yeah, you can kind of see that. So
and then when you touch the probe, we're going to see the face. The face is going to start looking correct.
Yeah, yeah. And I think for some reason I've done something. Let me disconnect that. I locked it up. Here's something I'm kind of proud of. So the reset button for this, I had problems on my previous one because once the SD card's engaged, you can't reset the P2 because it doesn't power cycle the SD card.
Oh,
I boot off of SD. Well,
you like cycle the power.
I recycle the power to everything on the board.
Awesome. Yeah.
And so it boots up and it goes through its little boot up routine there. Yeah, let me get that going again. All right, does my logo. That's enough time for the network to settle. All right, yep, we got noise there. And scope probe, we are looking at number 1. Spin this guy around here. Kind of give us a ground, I hope.
Is that ground to your scope?
Yeah. And
is the face still acting crazy?
No, not where I put the scope probe on it.
So it's okay, so that's good. Then if you take the scope, okay, so yeah, you're getting kind of 2 different voltage levels.
Yeah, isn't that crazy?
So zoom way in. What does that look like in detail? Just turn the or are you already maxed out on your horizontal?
So like the closer I get in, it gets dimmer, but it's still 2-stepped. And if I go all the way in, the shape of those guys are kind of goofy. Oh,
yeah, it should just be high and then low, right?
Yeah, it has that nice little half moon shape.
Is it a half moon shape?
Like whenever I go all the way in.
Because remember what you've got there is you've got 1K pull up and 1 milliamp pull down. Can you know where you wrote the OC or the C00? You did a right pin C00 to those 8 pins, right?
Yep.
Okay, so change that to a if we make them both resistor, it would be 9000.
Okay.
9. No, excuse me, 900. Just 900. Because the 9 is going to make the HHH and the LLL both 001s. So 900. So right pin 9 or set whatever you're doing.
Yeah.
Right 900 instead of C100.
Okay. All right.
And let's take a look at that waveform then.
Well, that's going to take me a minute to do.
Okay, don't worry about
but
it.
I'll
okay, go back to.
I'll give that a try with 900. Back to the scope.
Yeah, 900. So yeah, back to the scope and then looking at that signal. So what you had is you had like a fast rise and then like a or no, you had one of those should be linear. I think the way you had it, the fall should be a ramp, and the rise should be like a half moon. Should be
yeah.
Is that
Well,
what-
Yeah, that's opposite of what I was seeing.
okay. So you were seeing
Ramp
okay,
is straight
so-
up, and then the fall is.
okay. How straight up is the ramp? Because maybe you got the
It is vertical. It is like going from the bottom, just like almost straight up.
okay. Can you turn the speed of the scope up so you can look closer?
I think that's about all she's got, Captain. Let me try.
Yeah, you need more.
Yeah, there we go.
Okay, so if you had a resistor drive for the low switch, now you don't have it inverted or anything, right?
No.
Oh, wait a minute. Wait, you said C?
0, 0.
Oh, hold on a minute. Okay, well, I wasn't thinking right. C, okay, no, C00 is going to be, yeah, it's going to be 1100. So it's going to be, HHH is going to be 001, which means when you drive high, you're going to be 1.5 k ohms. And then when you go low, you're going to be a milliamp. Well, a milliamp is going to be like 3.3 k ohms. So maybe that's kind of like about right. A milliamp would so that, I guess that kind of makes sense. But that's not like high current drive, and it doesn't look like it's even reaching high and low states. And I wonder why. This thing must be marginally working, and then by adding the scope, you're getting it to, you know what? The scope, okay, the scope is going to slow down the rise and fall a little bit. Because that 10 puff load is going to, it's going to slightly slow down the rise and fall. And how fast are you putting data out?
800 kilohertz.
Okay, so that's a lot of time. I mean, that's like 1.25 microseconds, your period. And then it should move the signal in a couple nanoseconds. So it should be like very squarish looking. I don't know. You know that scope? Is that like a 20 megahertz scope or something?
Yeah.
Okay, so it's a slow scope.
Yeah, it's trash.
Okay, because you're not able to really see.
Yeah.
Yeah, so we don't really know what that waveform looks like.
Yeah.
Well, if you use 900, it's going to make it faster.
Okay.
Without completely swamping out the power supply lines. So that might help. But I'm kind of, Ada, why do you think it's mattering that when he puts the scope on there, it's changing the waveform enough to make it work?
Good question. I'm not a analog transmission line person, but I think what might be happening is just that by having more wire on the pin, it takes longer to drive the wire.
Yeah.
Right.
Wire.
Yeah, it's really weird because I mean I have longer traces going to this side of the board, don't have problems.
You know what? Let's look at pin 38 and see what it looks like.
It looks similar. So that's the thing is whenever I'm looking at it on the scope, I couldn't really tell any difference between any of them. But I can look. Unfortunately, I don't have the output but all the other outputs, it's solid. It's just crazy.
Yeah.
Have you pulled the edge out and just like blown on the contacts?
I have even swapped edges out.
Okay, so it's the board and not the individual edge. That's
yeah. I changed the entire edge out and same result. Yeah. All right. Well, I'm glad to know I'm not crazy because I feel crazy.
Well, I've had problems like this, and they're kind of tricky to resolve.
I mean, I can.
Go ahead.
I was gonna say I can survive with 23 out of 24 because that ain't bad. It's
No,
just
it should all work. It should all work. Um, you know, it might be that there are those traces maybe run parallel. And then by loading up one, there's like an aggressor. What do they call this?
Yeah, the aggressor. Yeah, so these are my aggressors over here, these guys.
Yes.
And these are my victims. Or
yes.
Specifically, the one on the very end is the victim. Everybody else is okay. It runs very close to a ground lead right there. And I don't know if that is causing interruption.
Ground should be quiet.
Yeah. I didn't know if like whenever it, the signal travels that close to it, if it's causing EM, some kind of weird common mode thing or what. But
well, what are these signals? What are they driving?
They're driving these buffer chips.
Okay, to just turn things on.
Yeah. Yep. So what happens is so the P2 puts out 3 volts, 3.5 volts, and I need a 5-volt signal to drive the WS 2811s, and because I have they're long, like 80 feet I have on some of these signals, and so I need the 5 volts to be able to drive them. And then also I've had lightning problems, which was nice. P2 survived and had to swap out the chips, and everything was good until I had a really bad strike that blew holes in the P2.
Oh yeah. Yeah, I wonder if P39 is compromised in any way.
Yeah. I don't know.
You're never reading it, right? You're just outputting.
Yeah. Yeah, all of those are outputs. And,
yeah, that's so weird.
Yeah, 1 through 16, completely solid, no problems, everything works. And
so putting the scope probe on there would add capacitance. It would slow down the slew rate. It would make it less susceptible to an aggressor. But it should be driving anyway. So
yeah,
it could be that within a brief instant, even though the pin might be holding steady state, an aggressor could make it look like it moved the other direction, and that level converter glitches because of it. Because at super high speeds, wires are like inductors, and the edge speed of a transition is like sub-nanosecond.
Yeah.
So something like that might be good. You know what might be good? Try making all those pins 32 through 38, but not 39. Make them all write 900 to them. Do a write pin 9, so they're going to be 1K, and then make pin 39, leave it as a full speed output.
Okay.
And just see if that, that way it's not going to be a victim. Well, the victim stuff can happen regardless of the state of the driver and the integrity of the driver, just because of the what's happening near the wire, that comes off the chip. And those signals, they go through those. Okay, so this is how you're shifting data out to the string of LEDs.
Yes. Yes.
I see. So if you get some data bit shifted too far,
you wind up with all kinds of problems.
You miss the clock effectively.
Yeah.
Okay, what about, there is another thing. Every pin has a different number of picoseconds it takes internally to get signals in and out. Maybe pin 39 is like, everything is under I think 800 picoseconds, but maybe that one's at the limit, so it's a little bit slow. So slowing it down gets it back into the clock capture phase. It brings it back into where it can be the setup time or hold time is not violated anymore. So there's something else. Are you clocking? You're not clocking those chips. They're just straight buffers, right?
Yeah.
Okay, so And how many, and you're only going at 800 kilohertz.
Yep.
And then is one of those signals a clock?
No. So what it does is it has a reset time that it performs, and once it goes high again, that starts, it's expecting input whenever, after it's been low for such a period of time.
Okay.
And it's really janky the way that protocol works, because you're not sending ones and zeros. It's based on the time that it's high and the time that it's low to determine if it's a 1 or a 0.
Yeah. Yep. Yeah.
Which I think is terrible. I think this is a terrible way to do it.
Yeah, I think what's happening is the thing is being aggressed on, and it's glitching, and it's being interpreted as a skinny pulse where you meant to have a fat pulse.
Yeah. Yep. And it's happening enough that, like, even even the ones in the chain that are further down the chain are being affected. Like, even whenever there's not supposed to be any signal, like it should all be zeros, it's saying, yeah, maybe that one's a 1. Yeah.
Okay, yeah, that would mean that as the pulse is going down the chain, well, is the pulse common to all LEDs, or is there some kind of line that?
Uh-oh, I'm losing you there, Chip.
Into one LED, out of that register. Sure. How about now?
Okay.
How
now
about
I can
now? Okay, might fade, but it could. Oh, am I back?
Yeah, there you are.
Okay, it just like kind of rebooted the whole thing. So, but this is, you're saying sometimes it'll go part way down the line, but then at some point in the string of LEDs, it starts to malfunction.
Well, so the way that it works is you're only driving that first one, and it takes all of the data that you've sent it and then repeats it, removes one and then repeats to the next one. So it's only that first one that's interpreting what's going into it.
Okay. But you're
so
saying you'll have like so many good LEDs, and then you start getting malfunction further down the line?
Well, it depends on the glitching. Like, whenever it's really bad, whenever the data is really bad, it's just it lights them all up and does stuff like that. And that's just a result of just the data being generally bad. Sometimes you're getting it off, like the way that it's configured right now with this amount of drive, you're getting it off by 1. The color's wrong, but everything else is kind of close. So it's close. That's the closest that I've got for that one pin. Everything else it's coming in correctly.
Yeah. So it seems like that inverter is seeing a glitch now and then. And then by you adding a little capacitance to that wire, you're slowing things down so you're not susceptible to whatever's inducing the glitch in your wire.
Mm-hmm.
And it's so then the inverter, or that buffer, is not passing that glitch on, causing the first LED to think it got a narrow pulse.
Yep.
800 kilohertz. Okay. Yeah, here's the thing. When those pins simultaneously change, right?
Mm-hmm.
You can see that what if one is low, but his neighbor shot high? Like, see, this guy's low, but if he stays low and his neighbor goes high, he could induce a high glitch in this guy, right? It could capacitively coupled. So what happens is they both go up. Well, this one a little more, and then this one goes back down. And so by adding capacitance, you're stopping the coupling. But it seems to me that if you were just driving these things with a full strength drive, it should work fine because you're not inputting anything. You're just outputting.
Yeah.
Like
I
you shouldn't
agree.
need to do a right pin.
Yep.
Yeah, I mean, you want hard drive because you don't want to be glitched. You don't want anybody to have a spike and to be able to have a spike induced into them because they're high impedance. You want everything to be as low impedance as possible.
Yeah.
Which means direct drive, like 0, 0, 0 for both high and low.
Yeah, I'm wondering if maybe I need to put a set of 100 ohm series resistors there and
Well,
and help with that.
Well, that would raise the impedance. It wouldn't lower it. Yeah, but you have something where some adjacent signal is toggling, like you're low and he switches to high and he glitches you high for a minute, or you're both high, he goes low and he glitches you low. So the only way around that is if you could maybe, but you're writing all of them at once, right? You're simultaneously causing them all to change states. So I mean, if two of them are neighbors and they're doing this, that's not going to have any effect. But if they're switching opposite or one switching away, he can glitch the other, which
is happening.
Yeah. So how could you do that? You could put little capacitors on every pin, but that seems kind of like overkill. I would just think if you kept, you were doing this with straight digital drive and it was not working well, right?
It on those pins, it doesn't. On the other pins, it's fine.
But on these pins, 32 through 39, that was a problem.
Yep.
And you were getting the same kind of problem where the face is looking funny, but you touch the scope probe to it and it straightens up.
Yep, that's what happens.
Man. You know what? Maybe there's an aggressor coming from elsewhere. Maybe there's some other high frequency signal that's capacitively coupling or inducing current into these wires that has nothing to do with what you're doing from your control.
I've considered that, and that is there are leads that are coming from the Ethernet that are sending signals back that I can't control the drive level, and I'm wondering if maybe that's it.
Yeah, I mean, whatever. Look at now. Is pin 39 the only one that has the problem?
Currently, yeah.
Okay, so something's aggressing on the wire that comes off of P39, and so you have to figure out: is that just a 2-layer board or is it 4-layer?
It's 4-layer board, and I put all of the high-speed signals on the other side of that board, and the stack up has a ground plane and a power plane in the middle. I spent hours and hours and hours of studying the way to do this, and and I'm like, what? I'm stuck.
Is there a way you could like have the internet unplugged and see if that stops it from happening, or so
I will give that a try.
Stop the signaling and see what's causing it.
I can build a custom program that could do that, and if that's it, then I guess that's it.
Yeah.
Yeah, I like that. I didn't even think to do that. I should do that.
You try to quiet down everything that might impinge upon that wire.
Okay.
And see if you can get it to go away. Some of these problems are real hard, and nobody gets to this stuff until they start building whole systems. Then they start having these weird things, and it's like, what is causing this?
Right. It's funny. This whole thing started with me redoing this is because pin 24 on the previous board happens to be one of the 360-degree Christmas tree, and pin 24 is the LED I have to look out my window at, and I see it glitch, and it just drives me crazy.
Yeah, you should be able to make this stuff so it doesn't glitch. You just got to figure out where the attack's coming from.
Yeah.
And then do something to mitigate it. Like just putting a little 10 puff or 20 puff cap on that wire will slow down. It'll like swamp out any aggressive spike being induced or coupled into it.
All right, I'm gonna have to take a look and see what I can do with that. But man, Chip, thank you for your time, man. I need to run.
Hey, okay, it's easier to solve other people's problems than your own.
I appreciate the help.
Right.
I'm gonna eliminate everything except for just sending the signals out that, and just start turning things on until it shows up again. And if it shows up on its own, then I'll know where to keep looking.
Yeah,
So.
debugging is always like figuring out how to cut the pie in half. Like, where's the pie and where do you cut it?
Yeah. If you have to cut it down the middle every time, usually within about 3 or 4 cuts, you'll find it.
Yeah, it's like successive approximation.
Yeah. All right.
Yeah.
Well, thanks, guys.
Okay, man. We'll see ya.
All right. We'll see you guys.
Okay. Bye-bye.
Bye.
Oh, yeah. Chip.
Yep.
Now it's the time.
Okay, so this little program you're talking about?
Yeah, I pasted it in the chat. Yes.
Okay, let me see. Chat. Here we go. Pastebin.com.
Yeah, it's just where you post files, because if you post it into the chat directly, it will get rid of the indentation.
Oh, what does this do?
Guess what it does? I've removed the comments, so it's more funny.
It's load bearing. Let's see. So it's 100 megahertz. No, 0. Okay.
You can just run it. Just run it with debugger enabled. It will do things.
Okay. Do I need to? Let's see. Okay, so if I grab it, then let me open up the thing here. There we go. Okay. Okay, run it. Wait a minute. Oink, oink. What?
Notice what has happened to the debugger.
Okay, so it's counting 0, 1, 2, 3, 4, 5, 6, 7, 8.
No, notice what's happened to the little thing that the debugger prints before the debug.
Oh, okay. This is your thing where you can interrupt breakpoint, right?
Yeah.
So how did you, okay, so your oink oink thing is down in the p text.
Yeah.
Okay, so what you did is you redirected it. Wow.
But no, notice that afterwards the debug is still changed, right?
Well, it's just counting now.
Notice the cog counter. It doesn't say cog anymore.
Oh. How did you do? Oh, so you were able to like do a write into the program memory where the C was stored. Is that right?
Yeah.
Write long. Okay, there it is. Oh, wow. So that's pretty clever. So you found a way to bypass the debug thing. Well, I guess this is like how vulnerabilities exist.
Yeah, this is.
Hopefully
but look how it's done. It's kind of interesting. So the initial idea was, what if I have the FIFO running while in debug mode? Does the FIFO start being able to write into it? And the answer is no. That's actually good. The FIFO apparently can never bypass the write protection.
Yeah.
However, it can do something far better. That's way better.
Wow. 62.8. Interesting.
Basically, all the interesting stuff is in the inline assembly snippet. The very lovely benign function here. That's what gets called when we're already in the bad.
Let me start this again. Huh.
And the most interesting thing is this probably will stop working if you try to single step it.
If I do what?
If you try to single step it, it will probably stop working.
Oh, yeah. Interesting. Well, that's pretty clever.
What actually happens here is, you remember that thing where if you do the weightless RD fast, it can like corrupt the normal reads and it can apparently also corrupt the normal writes. But in this case, what happens is that if you fudge it so that the FIFO is already busy and then you start the RD fast, and then the next instruction is the beginning of the interrupt, then you can extend it just long enough so that the first instruction that it loads from the debug area gets just doesn't get loaded at all.
Yes.
So that's why we're moving into register 0. It's because that then doesn't get loaded, and that's just an instruction that it runs.
I would have never thought of any of this.
I don't know, I was bored or something.
Well, good job. Interesting. A security vulnerability, although the security is really only kind of like a polite security.
Yeah, I mean, you can do all sorts of things that the debugger won't like.
Yes. Wow. Oh my gosh. Well, thanks for showing me that. This was you had a thread about this that I read, but I didn't. I kind of got the gist of it, but didn't really ever run the code.
Yeah, this is the other I mean, the code that's in there, it has a little bit more comments. I just removed the comments for comedy purposes, you know. Well, they're not that much better. And of course, having the text just as a byte array is ha 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 ha. You can't see what the text is without thinking about it. You know, comedy purposes. I mean, this entire code is comedy. It changes cog to hog.
Well, good job.
And maybe you should make a P2 that has hogs instead of cogs. Oink oink. Well, that's the thing, right? Maybe that's a version of the P2 that instead of the egg beater model has like a crossbar thing with like first come, first serve, because the cogs, they just rotate around, right? But the hogs, they all want to get to the food, and the one that gets there first wins it, right? Oh no,
Breaking enigma.
The connection just dropped.
Connections. I know. Okay, well, hey, I should get going because my wife's back now, and I got to talk to her.
Ruminate on the difference between cogs and hogs.
Well, I think this 72, what is a 72? Alt. Yes, there's your 72 is the ASCII H.
Yeah, and the one above, the number above, is just like cog 0 or whatever it has in the debugger ROM. It's just looking for that and patching it.
Right. That's pretty neat. Oh, I see. You've made it even kind of version proof because it goes around and figures out where it needs to put it.
Yeah, exactly.
Yeah. Very
Mostly
good.
because that's easier than figuring out like where to actually put it. Right, like we'd have to like assemble the debug and then like figure out where to put it. No, just do this.
Yeah. Pretty good. Yeah, I see
Yeah,
Edgardo is here. What, Ada?
Nothing. I just said hog, possibly.
Okay.
Oh yeah. And also, why is the first debug load bearing? There's something. That's another one.
Because you need the break instruction there.
No, that's the second one. That's the oh no debug.
Yeah.
The first one's actually needed because when you corrupt the second
Oh.
debug, it destroys the registers that you had. And since this code is so short, it will not properly return if the registers are trashed.
Okay.
So the first one just makes sure the registers are actually saved.
Right.
That's why it's load bearing.
Cool. All right. Someday I might look at that really hard and figure out exactly what it's doing and see if there's anything we can do to prevent it.
Well, it's really just an application of that RDFast bug. So if that's fixed, then
Yeah.
that just
So okay. So once we don't allow the MSB.
No, it's not like you don't allow it. It's just you fix the issue. Oh, it dropped out again. Oh
Wait,
no.
say that again. We're breaking up.
Yeah, you don't have to disallow the MSB. You just have to make it not glitch the rest of the everything.
Yeah, but this whole thing is enabled by the MSB on a read fast, right?
Yeah, exactly. That causes
Okay, so that we're at the very end.
Oh, it's breaking up very badly.
I mean, not really thinking so much. Okay. Well, hey, I should go because I gotta
The Ele mouse will get to you.
off this thing, but we'll see.
I can literally understand nothing.
In a month.
Literally understanding nothing here. It's just super glitch. All of it's busted.
3 weeks at this point, I think.
It's mega busted. I don't understand anything anymore.
Can you hear me, Ada? The meeting. Ada, I can barely hear you. You're breaking up.
I can barely hear you either. It's completely busted and bad.
Okay, now I'm going to hang it up. I don't know if we're still on. Here we go. Bye-bye, guys.
Bye.
Bye-bye.